All right, well, welcome everyone. I think we're going to go ahead and get started. I want to welcome all of you to the 2024 Paradata Workshop. Those of you joining in person, thank you very much for being in Ann Arbor with us. So we're happy to see so many of you here. Also, those of you joining online via Zoom, very happy that you're joining us as well. And we're really looking forward to a fruitful and productive workshop over the next day and a half or so. My name is Brady West. I'm a research professor at the Survey Research Center here at the University of Michigan Institute for Social Research, where this is being hosted. I'm also a research professor in the Department of Biostatistics at the University of Michigan School of Public Health. And again, I'd like to formally welcome you to the 2024 Paradata Workshop. For those of you who are new to the concept of Paradata, these are unique data that are collected to describe the process of gathering survey data. And we're going to hear a lot more about a working definition of Paradata from our opening speaker here in a second. But Paradata generally include information about how survey data are collected. So this could include timestamps, interviewer notes, response patterns, and other contextual details. These data provide really useful insights into the quality and reliability of the survey data that we're collecting, and they help us understand the factors that may influence responses, such as the timing of interviews or the methods used to reach participants. We hope that by better understanding Paradata, we can improve the designs of our surveys and the data collection processes. So we're very honored at this workshop to have pioneers of the concept of Paradata joining us to share their research and guide our discussions. So these collaborative discussions over the next day and a half are going to help us to identify challenges and opportunities and surface ideas for new applications of Paradata. There was a previous workshop on Paradata in Germany in 2011, and that workshop led to the publication of a very popular edited volume on Paradata that was led by Frauke Kreuter, who's going to be giving our kickoff talk. And that was published by Wiley in 2013. We really felt that an updated discussion of what we've learned about Paradata in the past decade and how it can help us to improve modern survey research was well overdue at this point. So we hope to make a contribution to the field from this workshop. And to that end, the presenters today and tomorrow are going to be invited to submit their work to a special issue of the Journal of Survey Statistics and Methodology. And that special issue is set to be published in 2026. So there'll be more details about that forthcoming. As we've seen over the past day and a half here in Ann Arbor with the 75th anniversary celebration of the Institute for Social Research, it really takes a village to make these kinds of events work. And we've had a phenomenal day and a half celebrating ISR's 75th birthday. But I'd like to thank the other members of this particular workshop's organizing committee, Kate Cagney, the director of ISR, who's with us today up here in the front row, Mick Cooper, who I believe is joining us online, and also Tom Crosley, who's here in the room with us. So really enjoyed working with everybody and organizing this workshop. So really looking forward to it. I also want to thank the Institute for Social Research for sponsoring this important event, and especially the ISR staff, in particular, Catherine Pearson, who's going to start off moderating today, Yelena Muthiala, who's helped us a lot with the website and online materials, and also Anna Massey, who helped us with organization and collection of the materials. So very grateful for all of their help. In addition to all of you who are joining us at ISR today, we're going to have over 120 participants joining us via Zoom. And so for those of you who are joining on Zoom, please feel free to enter any questions that you might have about the talks or the discussions in the chat. And we have moderators who are going to relay those questions back to us in the room. So we'll make sure that everybody hears what these questions are. But please don't hesitate to submit your questions remotely via the chat. We have a team that's going to make sure to answer them. So I encourage everyone to engage actively in this workshop. It's very much meant to be an exchange of ideas. So that's very much what we're looking forward to. And to network with one another. We have people from all different walks of the survey research life here. So meet some new people that you don't know, have some discussions. We're going to have lunch together tomorrow. We'll consistently have snacks and refreshments in the back of the room. So there should be plenty of opportunities for discussion. And I'm really looking forward to exploring the transformative potential of Paradata in our research and its implications for our field. So a little bit more about the workshop format. We're going to have a mix of live presentations from individuals who are here with us in Ann Arbor, but also individuals who are joining us remotely from all over the world. So we're going to hear presentations from people in all corners of the globe. Each presenter is going to have about 25 minutes for their presentation, and then we'll have 5 minutes of Q&A after that before the next presentation starts. We're also going to have breaks spread throughout spread over the next day and a half. I'm going to keep the time for each talk as a moderator, so I will interrupt the speakers when they have 5 minutes and 1 minute remaining, just so we can keep things on track here. Again, we're also going to have refreshment breaks that are scheduled regularly across the day and a half for those of us joining in Ann Arbor. So again, welcome. Without further ado, I'd like to get started with our first presentation. So Frauke Kreuter is going to kick off our workshop with a talk that will get us all on the same page in terms of the growth of Paradata and what we've learned and how we currently define it in the work that we do. And of course, its potential utility for modern survey research. I do have to recognize that Frauke gave the final keynote in the ISR 75th anniversary celebration. So literally an hour later, she's kicking off this workshop. So that's how important Frauke is. So really happy that she agreed to do this, especially with these kinds of back-to-back presentations. So Frauke is from the Joint Program in Survey Methodology, and I want to give her a warm welcome. So thank you, Frauke.
And I thought you mentioned that other presentation to explain why I might be less energetic than I normally am. So I feel a little, but thank you for allowing me to kick this off. And I, you know, as this sometimes happens when there are too many events cobbled on top, I had forgotten the exact title that you gave me for this presentation. And then I realized that my talk maybe would have deserved this title much more so, because I realized that this is basically what I did the last 25 years, or, you know, maybe not the last 5, but for a long time. And it sort of coincides, and I was all in the mood of looking back, given the anniversary. And so anyway, I you know, some of you might transition from a day and a half worth of content, and I'm trying to ease us in, you know, into this. And so the most important piece first, I learned this from The Economist, right? This is the slide to take pictures of, maybe. If you haven't seen, there's a new book out called Perspectives on Paradata. And a student of mine, Patrick Schenk, and his collaborator, they wrote sort of their version of history summary on Paradata, and they proposed this, you know, definition of theirs that is a little wider than we've seen in the past, but they also volunteered this nice little picture, which I think is helpful to set the stage for anyone here in the room. And by room, I mean the physical and the virtual room. And I know that there are a lot of students, in particular online, that weren't able to come here, who might not have seen this whole context. And so I'm trying to give a bit of context. The most important piece is that there's always a confusion: Paradata, metadata, what's one, what's the other, what are auxiliary data. Not every publication is using the data in the same, the words in the same word, the words in the same way. And the interesting part about that Paradata book that came out is this is from a completely different discipline, you know, I mean, and so if you look at the table of contents here, you know, this is about archaeology and law, and I'm like, you guys are using the word Paradata? That was really stunning to me. When they approached me first to write a chapter, I thought this was one of those scammer conferences, you know, where it's like, you don't even belong to that field and they still want you to like pay $2,000 to come. So that's not one of those. It's just that this is actually a concept widely used. And in the survey field, the word Paradata is often used sort of to describe data at the micro level, as Brady already mentioned, that come alongside in the process. And it helps to look a little bit at the history, because I feel like many of us operate with the word Paradata sort of in this, you know it when you see it kind of way. We learn by examples. This is an apprentice model, but it's also a mindset. It's a mindset of controlling, or like knowing what's going on by taking all the information that you have alongside. And obviously, a kickoff of such workshop cannot happen without recognizing with Cooper, who has pushed, you know, all of us into that direction. And the omnius, like, when was the actual first publication of that sort question? My recollection of this was, if the term was used at a joint statistical meeting in 1998, where Mick called the data as such, but in the preceding paper that went with that publication, it's actually not mentioned. So it's always a little funny to cite Paradata in that proceedings paper, and then the word Paradata doesn't appear there. The other interesting thing is that any one of you entering the field later on might think this has always been around. And I, this happens when time passes. And I was reminded of that when my niece came to visit in Washington, D.C. She was at that time, early teenage years. And then we went to the National History Museum, and she saw that timeline of US history, and then YouTube being, invented or started in like 2001, which was the year she was born. And her mind blew. It was like, what? This has been around forever, because in her life it has been around forever, but that it wasn't older than she was nothing that she had in mind. And so this, Mick and his colleagues using this term for the CARTI keystroke data and confronting it in that way had a similar effect on me. Then, because when I entered the field as a graduate student in Germany, collecting my first set of Paradata in 1999, I too thought, oh, this must have all been around forever, not realizing that I was engaged in an activity that basically just started, right? So that was my YouTube moment here. I was joking with James yesterday, and I said, I wonder if I still have pictures from that time. And I did indeed find some emails where the pictures were attached. So here they are. The interesting thing is so for context, this was a study where we created the sampling frame ourselves in Germany, and while listing the addresses, did interviewer observations of the housing units. This was a survey on fear of crime. We recorded physical signs of incivility in the street. We recorded housing unit signs on whether there's alarm systems present and what have you. So any proxies for fear of crime that might correlate with non-participation in the survey and things of that nature. In this listing, and this is why I thought the picture was sort of useful, we had used, a set of handheld devices that aren't even available anymore. We had no money either, so we went to the local store that sold these and says, like, we have this research study. Can you give us 5 devices? and then entered everything in like tiny little spreadsheet, Excel spreadsheets to do that. Obviously, these days, other technology is around, right? But what is still around in the same way is the interesting information that you can get from these contact records, so this is as the first step, the housing units, but then the next piece to it that we insisted that each of the 5 surveys that were conducted with the frame that we created would use records of their contact attempts. Because in the British Household Survey, and these are the 2 graphs that you see here, we saw that the probability to become a victim, which is the y-axis here, Anteilopfer, for those of you who want to practice their German, the proportion of victims is correlated, or seemed to be correlated, I should say, with the number of contact attempts it took to get to that interview, which makes perfect sense, because a lot of the victimization that's asked for is victimization that happens outside the house. If you never leave the house, you're less at risk, right? Well, actually, the ones that I show here is the opposite, right? So if you're outside the house a lot, then the first one is victim, like burglary. Einbruch is burglary. So the more you're out of the house, the higher the proportion of people whose household have ever been burglared. That's the graph that you see here, right? So so anyway, the point being is that these contact records in those early 2000s were not a given in many surveys, not at all. In fact, it wasn't until 2004 that the National House Interview Survey had this contact history instrument, the CHI, which is this screenshot that you see here. I should use the mouse if I know where it is. Anyway, a clunky instrument, and anyone looking at that and caring about interviews already feeling a little sad that they have to, be confronted with that Blaze interface, or at least back then in the time. In many surveys, the European Social Survey still had that on paper, right? That's the screenshot that you see on the bottom there. For those of you new to this, what do these interviewer observations and the contact history information give you? It gives you variables that you have both for respondents and non-respondents, ideally, it's a little bit of a signal for those people for which you later on cannot collect any data, right? That's the main purpose why these are collected. And this set of paradata, so the observations of the neighborhood, the contact history data, anything that you can get to either the entire frame or at least to respondent and non-respondents, is hopefully of value and carries a signal for what we want to do. This also already foreshadows what's sort of inherent in this definition. It's only worth collecting these things if you think they have anything to do with what you want to collect, right? I'll get to data sparsity at the end, but the more we are able to sort of do surveillance and collect just about everything people do, the more tempting it is. But if it is not predictive, then maybe we shouldn't, you know? And so this would be on the content side, the CATI instrument pieces that we saw earlier. Keystrokes are augmented by Blaze or other instruments, you know, records that you can capture. The reason I gave you this screenshot here is because for a long time, our ability to do something with these data was sort of limited by researchers' ability to sift through messy files like this. And obviously there, a big change has happened, not just with the advent of the new chatbot models that can create a rectangular data set out of this mess in no time, but also even prior, you know, with machine learning models helping us to create valuable features out of these, find patterns maybe where we don't, where we wouldn't see them ourselves. And these patterns, whether it's on the measurement side or back to the non-response side, were something that you know, in 2006 then was a big push at another sort of innovation tied to paradata in the field, which was the notion of responsive design, that we would tailor our recruitment strategies based on what we learned did work or didn't work in prior ways, right? And it's interesting, if you're new to this field, you might read everything about paradata and never come by these responsive design literature. But to me, both of them are really intertwined, you know, because it's a nice application area where you can see this kind of data or any other data, auxiliary data that you might find somewhere else that you can append to the individual unit, can be informative and can steer what you do. Continuing the memory lane, 2008 was when Mick Cooper was awarded with the Warren Mitofsky Innovator Award to use paradata to understand respondent behavior. This award was not for, hey, we can use the CATI keystrokes, right? This award was awarded for seeing there is a way to have a second data stream that helps us do better, in particular in places where we don't have a gold standard, where we don't quite know what's going on, right? We're monitoring the process and seeing unusual things in the process can lead to discovery of a problem, maybe of the need to train an interviewer and whatnot, and the subsequent impacts that this had on the field. One such example for new tools that weren't captured by that initial suggestion on using paradata certainly was that in 2008, you know, I couldn't find a nice image of Toby, but some of you might remember there was a sort of a wave where everyone bought these screens that had, like, you know, infrared or something, you know, like, you know, beams coming at respondents' eyes to reflect on the retina, and then we could see on the screen where people look and whatnot. I haven't seen any papers lately use this, you know, technology is sort of like many technologies, it goes up and down in waves, but it had this same effect on discovery. And I pulled out one paper here that Nick was also involved in, but others too, methodological, Roger Terencio and Fred Conrad, who if they're on outline, hello, which was so interesting because you could watch a whole bunch of respondent answer questions and see and learn what they're doing as they go through the answer options, right? Is that, you know, do they find their answer right away? And then noticing that sort of they pick an answer, then read what else is there, you know, and then pick the next one that might be relevant, read, and they're sort of typical strategies on how to do that. And we'll hear in the next talk from Sonia Graven that, you know, a proxy for some of what you can learn here can be captured by mouse movements. You don't necessarily need the elaborate techniques of eye tracking, right? But that was certainly a technology that came around. Why am I showing this? You know, already the 10 years that you've seen till here shows that new ideas for what you can capture as paradata come along as technology advances, right? And as we build technology in our data collection, that's why defining paradata and learning about them as this particular data type makes no sense, right? Because the new technology will have new data types. That's what I meant earlier with the mindset and the spirit of trying to capture what's going on. However, not to overlook that there were also new analysis tools that came around. You know, the sequence analysis was a technique that sort of, you know, popped up in popularity. There were new methods developed or newly implemented, in this case, possible to do it with data. And all of a sudden created the possibility for us to look at a lot of paradata that happened longitudinally. So not just contact attempts, you know, trying to create features out of a contact attempt, you know, history record, but to see, okay, does it matter in which order I capture someone? Is there sort of a digital footprint of what happens to the respondent over time for one contact attempt or across multiple panel waves? Gabi Durand over in the UK has worked on that quite extensively thereafter, right? So this is quite interesting to see how both, you know, the development of new technology and the development of new tools sort of fueled the fields, right? And I can see a similar moment right now, you know, as these new AI tools might help us, you know, analyze the data in a very different way than we've done before. The need to rely on something in addition was also elevated as we took interviewers out of that process, right? Andy Pachev wrote his dissertation here at ISR 2009, you know, had this nice graph in his dissertation on looking at breakoffs at certain points in time throughout the questionnaire, you know, indicating there could be a problem, indicating maybe how you interpret the non-response downstream, how you would impute based on where people dropped off and the like, right? So this kind of additional piece of information that you need even more when there's no interviewer present might be important. But as I said, only if related to the outcome variables. And again, this feels like something we now preach, or it feels like preaching because everyone learns that in their courses. But when we had what Bob Gross and Trivia Raghunathan back then called Club C, where, you know, a bunch of graduate students, many of them in this room here, and these two professors got together to think through, you know, what kind of information should be captured, right? And it culminated in that paper here. But for us, it was so interesting to learn from someone with such stature as Bob Gross, that he says, like, I never, when I wrote that survey error and survey cost book, I didn't think of it that way. I didn't think of the relationship between these auxiliary variables that I would try to use to correct, and the, I mean, that there needs to be a joint mechanism. Otherwise, it's not useful to have that information for the non-response adjustment, right? And to sort of this shift in perception on what's worth collecting and paying attention to was one that we felt sort of happened during that seminar, and that was a quite pivotal moment. So all of that Brady already mentioned, it accumulated in this conference in 2011, and more structure around this whole field, right? Eventually the feeling that every stage of the response process could be filled or underlined with paradata that you can collect alongside. The framework, I mean, maybe there needs to be another award for just that picture. I don't know how many pictures a survey, like how many survey talks had that picture in it. But it is quite striking how useful it still is, you know, to sort of think through, okay, these are the steps I'm having and what happens alongside, and then maybe fill missing gaps of a paradata collection or something that could help understand, quantify an error source, and maybe do something about it, right? And so, you know, you see here, missing a pointer, but you see here, for example, for measurement error, something that initially wasn't necessarily on our radar in these discussions, but capturing something about the interviewer's voice, about the interviewer interaction with the respondent, is clearly something that happens in that process. The data can be collected on that, and these days analyzed better than ever. But also back then, we were able to do it on a set of cases, recordings here at SRO, just of that the beginning snippet, to see if there's something about that interviewer, how he or she approaches the respondent, how the speed of which they answer, how they adapt to the respondent characteristics when they talk, that could be predictive of participation or not. This paper with colleagues here at Michigan, also from linguistics, was an incredible hit, like a 1 day, 1 week blip on countless media outlets. I've just put BBC News here, but there were many others. The reason I loved this so much is it felt like, oh wow, we're having it. I mean, journalists love this because that's what they're all about, right? Talking to people. They could sort of relate to this piece. And they found it fascinating that we saw that if you're too scripted, too monotonic, or too fluent, that both of these are bad in recruiting people into the survey, right? And that was an insight. No one had any idea that the rate of speech would matter, that the way you argue, and talking to folks right now that do interviewing or calls in leading up to the election, certainly a similar setting, right? A lot of the times you very quickly need to adjust to a respondent and do the right thing. And, this kind of adaptation, or this kind of learning and helping to adjust, is something that can be very challenging. And certainly these days also, with AI around the corner, could be a way to improve this. It's certainly, this one here solved the puzzle on understanding why certain interviewers are so much more successful than other interviewers when they try to recruit people to come into the survey. The focus on interviewers really is something that Brady then took forward the next 10 years or so in his research. The first, one of the earlier pieces was this 2012 piece on quality of Paradata. So it felt a little bit like meta research, right? First, we had the Paradata to look at the quality of the survey data, and then we had the string of research that looked at the quality of the Paradata, right? And it felt like a little bit turtles all the way down. But this was an important approach, important insight from, or vision of Brady's, to look. It's like, okay, what is it? How good are these data themselves, and can we make it better? Can this instrument, which is strong, be even more improved so that we can do something with it? And some of this work, but also others, similarly improving both the methodology with which the data is analyzed, and the data themselves was then part of the special issue on Paradata that came out in 2013 as part of the Journal of the Royal Statistical Society. I already mentioned Brady had this renewed focus on interviewers, but he wasn't the only one. Chris Knowlson, James Wagner also looked at this and threw in another piece, which was, GPS data, cost structures. Technically you could argue, well, our cost data, Paradata, or the auxiliary data, as I said, don't get hung up on these questions, but basically this cascade of additional things that we can use to learn about a process. You might wonder, what is this graph on the right here? This is my most beloved, never published graph, or at least not in an English-speaking outlet. As part of my dissertation, I mentioned earlier that data collection work with the picture that you saw. One of the surveys that was done with these frames was a telephone survey that had everything else. I mean, frame data, locations, questionnaire, everything else the same as these other surveys, but was done on the phone. And we were interested to see the effect of an individual interviewer to the resulting values, the resulting statistic. And because this whole thing was an interpenetrated design, we looked at sort of what is the row, the interclass correlation coefficient that I get for a certain statistic when I drop one interviewer at a time, and with the assumption that, if the unusual, I mean, so you know, some when dropped would increase row, and others when dropped would decrease it, right? And we noticed the one that when dropped increased row was a supervisor who was just very good in doing these interviews. The one that decreased row when dropped, right, was the only male interviewer among a set of female interviewers, and therefore, you know, creating significantly more homogeneous and different answers than anybody else, right? The reason I bring this in here, because this is an example for not having any paradata except interviewer ID, you know, and just the ID itself, you know, can help you do analyses like this one here, seeing how the interclass correlation coefficient changes over time, and can be a signal for what's going on. It is one interviewer driving a result. And, you know, up to this date, it's still not common for all surveys to have interviewer ID as part of the package that they publish, or a version of an interviewer ID that doesn't reveal the interviewer itself. But it's still something that I feel like, you know, it is a super valuable item. And I'm very happy to report that many surveys do it now. It's just not everybody. Anyway, moving closer in time, mouse movements, we will hear much more about that. I mentioned that earlier. The reason I bring it up here again, the mouse movements, as well as sorry, jumping to it. The mouse movements are, you know, if you think about capturing these patterns that someone leaves with the mouse in a statistic or in a feature can be quite challenging, right? Do you, and we'll hear more about that from Sonia in a moment, you know, do we, you know, cover how long someone takes, you know, do we cover the straight lining one? There's many features that you can generate from it. And sometimes, and this is something that Mick Cooper in this overview talk in 2017 pointed out so clearly, is that despite all the maturity that the Paradata have had at that point, that the lack of standards on how to collect it and the unstructured format of the data that come in often held us back a bit in taking full use of these Paradata that are collected alongside, right? And there's still room to improve here. The standardization has come a little bit more in you know, through efforts from, you know, want to recognize here other students of the ISR program, Colleen McLean being one, who sort of pushed, okay, can we think about typologies? You know, others tried to think about standardization in how the data is collected, and some of it found its way into this report from the National Academy of Science, pushing towards transparency in data collection and unified standards across the big national surveys that are collected through the federal statistical agencies, because they're realizing as this whole data collection endeavor gets more complicated, mixed mode and whatnot, we can't have entirely unstandardized or no paradata. We need a little bit better overview of what's going on and what decisions will be made along the process. So for those who haven't seen this, I'll highly recommend that. And then couple of more slides, just, you know, looking at others that collect data, not the survey community. This whole discussion on NI, and we had, you know, just in the previous conference, alluded to this, has also created awareness of need for collecting good quality data among the computer scientists. And they also came up with the push and need for having more standardized ways on talking about how the data collection was done. And one example is this data sheets for data sets by Tim Gebru and a colleague of mine in Maryland, Hal Daum, he was back then also at Microsoft Research, and other colleagues. And it's interesting because their rubrics are all sort of descriptive. It's like a narrative. What have you done? What have you decided to do? When, or how did you make this decision or that decision? But it's the other extreme of the kind of paradata we have, but maybe something that gives us ideas here as we talk today and tomorrow about how this can be done. Similarly, if you think of all the data collection effort that's going on to train these data collection models, a lot of it looks like web surveys. A lot of it is annotators, just, you know, clicking a button. And here too, no collection so far on how that is done, how it would fielded, you know, timestamps and whatnot. And they too certainly could benefit from all the insights that came out of this community and already will to improve the data collection they do. So in summary, this field has matured a lot. It found a solid place in creating higher quality data. The field stays busy because there are new tools coming around all the time. And it really has, I think, shown its value for processes and documentation where we don't have a gold standard. We're looking at the process as our only way to see whether we did a good job or not. I'm hopeful that the advent of these powerful AI tools can help us to overcome these unstructured and messy data examples that I just showed you. And as I mentioned before, and I want to reiterate that here, only because we can, that doesn't mean we should. It's always helpful to think about, do we really think whatever data we collect could be predictive of something meaningful that is related to one of the error sources that we're worried about? If not, then maybe we just don't need to collect it in the first place. Thank you very much.
Great, thanks, Frauke. We have about 5 minutes for questions, so I can just bring this mic around, or if there are questions on Zoom again, please enter those in the chat and our moderators will call those out. So any questions for Frauke? Okay.
Thank you, Ari, for breaking the ice.
Well, also, it's actually not a question. So sort of a generous definition of Paradata, I guess, includes mode effects, because what you use, it would include interviews. So I think one dramatic example that in my sense is still underappreciated during COVID, as you probably know, unemployment rates went up tremendously. And so the unemployment rate in April or thereabouts 2020 is quoted as being about 14%. However, if you read the documentation of BLS, then one of the things they'll point out that their interviewers started misclassifying unemployed as actually having a job. Moreover, as a RAND paper pointed out, because of COVID, no longer in-person interviews were done, so they moved to telephone. The result of that they were missing more minorities. If we add it all up, the true unemployment rate is actually 20% and not 14%. And I think an example if you sort of realize that, how these things can affect what you seem to be measuring.
Yeah, so let me see if I understand the point you're making. So what you're saying is that not only will it detect problems like errors that happen, but also just shifts in how the data was collected that could be correlated with other ways. So it's not technically an error, it's just a shift in process, and the other, as we know, different modes or other changes in process lead to different results. And if we want to have historic comparability, these data are one way to make sure we're comparing apples to apples. Yeah, that's a very good point.
Yep, Catherine. Yep.
We have a question from Zoom.
Okay.
And I'm going to apologize for, thank you very much. Can data on IWER training be considered Paradata? Thinking of things like noting questions asked, noting types, and frequency of errors, trainer slides. I'm sorry, that was supposed to be interviewer. Thank you.
Yeah, I got it. I think we used that.
Seen that before.
I would, if we I'm not sure if we use that definition that Patrick and his colleague put together, or this graph, as a way to guide our thinking here on whether this, we would call this Paradata. For me, well, first of all, I'm not wedded to these words as much as I am to the concept, right? But in terms of words, I think if we do expect there to be variance on the micro level, then I would say, yes, it is like Paradata, because you could attach to every, there's the camera on that. So you could attach to every person an information about, how many hours of training the person attended, or how many, mistakes or troubles the person had during training or whatnot, and that could shed light on this. If it's information about the training itself, the hours of training that were done for that survey, or this is the training material, then I think this would probably more likely fall in the bucket of metadata, sort of, you know, like a response rate or like labels that are associated. So depends a little bit on whether you have microdata and there's reasonable variance across the interviewers, whether we would typically think of it as paradata or not.
Yeah, I think an important distinction is, did the data already exist before you started any of the training, anything to do with the interviewers, any data collection activities, or were the data generated once you started the activities? I think that's a very important distinction. So, okay, maybe one more question, if anyone has one for Frauke.
This might not be super well formed. Do you, like, I kind of agree with you that sometimes we think, let's just collect all the data we can. I wonder if you have examples or concerns about when the collection of paradata actually is interfering in the survey process. I'm thinking, I mean, at the most basic level, I've seen situations where capturing response times on survey questions is actually slowing down the entire progress of the instrument. But I'm sure there's other examples.
And this is a great point, Cameron, that you make there. I have, we've seen this a bit with the interviewers, you know, because they like to do interviews. They don't like to fill out forms, you know, and so, you know, layering on, you know, I mean, already the contact protocol data are sort of a nuisance, and it would be better if this just happens automatically, right? And, or filling in the time, beginning and whatnot. And so I think, yeah, I can definitely see that. You know, the other application area where this comes to mind is voice recordings, you know, that require consent. You know, that is an additional step. It could lead to breakout. It could change the answers. So I think that is a valid concern. I'm not sure if I have seen enough literature on this particular piece to say these type of data lead always to that kind of problem, but I think it is something to keep in mind for a given survey or context, for sure. Yeah, very good point. Thank you.
Okay, thank you again, Frauke. Okay, our next presenter is going to be Sonia Graven, who's joining us remotely from HU Berlin. She's going to be talking about classification ensembles for multivariate functional data with application to mouse movements in web surveys. So as Frauke was just alluding to, some of the new and exciting research that's going on with mouse movements.
So yeah, this is joint work with Frauke's group. You can see most of these authors are from her group. And Amanda is the first author, is a former postdoc on this project who did most of the work. Okay, so the motivation comes from, as Frauke already talked about, survey research, where one particular kind of paradata that's being collected is paradata in web surveys. And we are in particular looking at cursor movements or mouse movements in these web surveys while people are filling out the survey. And the idea is that there might be information contained in the movement patterns about data quality and potential difficulty that people are having while filling out the survey. And one feature that's sometimes used is just the total response time that people take while filling out. So response time has been used to detect problematic survey questions, for example. But then also it has been recognized that other kinds of features on these mouse movements might be informative. So for example, features such as the periods of inactivity or hovers while people are filling out the survey, or also how often they might be changing the movement direction of the mouse in, say, X or Y direction. And so Frauke and myself, we have a project funded by the GFG where we wanted to look at whether there's actually more information contained in these mouse movements besides any features that we might extract a priori, and whether we can learn more about what people are doing while filling out the survey from these mouse movements, and in particular see whether we can understand whether there's any difficulty with the question. So the short-term goal of the project was really to see whether we could use these mouse movements as predictors to predict whether someone had an easy or a difficult version of the same question in a setting where the question difficulty was actually manipulated. And then the long-term goal, if this works well, would be to actually use these tools to then learn from the mouse movements and use that to improve data quality, say by detecting difficult items, or by offering online assistance, say, or by using the information to then maybe correct for measurement error or non-response later. So the data we had available in the first planning period, we are currently rolling this out more and getting more data, but here we had data from this survey from 2016 called Challenges on the German Job Market. And this was done in collaboration with the Institute for Employment Research in Nuremberg. And they had contacted people, respondents from a previous survey who had agreed to be contacted again. And they got also a €5 incentive, and the response rate was pretty decent. This included both employed and unemployed people, job seekers, recipients of unemployment benefits, as well as active labor market program participants. There were about 1,200 participants in total, but only about 890 of those reported using the mouse. So that's the subsample we focus on here. And about 850 had mouse tracking continuously available. But for specific questions, because they didn't always apply to everyone, the sample size may actually vary. Okay, so that's the survey overview. We focused on this particular block on employment and some opinion questions as well. And in particular, within the survey, some questions were experimentally manipulated to create always one easy and one difficult version of the same question. And then the question was whether we could see how these manipulations systematically influence the cursor movements. And then the more difficult question also to turn this around and say, well, can we also detect from the cursor movements whether someone was filling out the easy or the more difficult version of the question? That's the more difficult problem because, yeah, if you do see some systematic changes, there might still be a lot of overlap, and then the prediction might not work so well. I'll be focusing on 3 questions, mostly on the first 2 of those. We call the first one employment details. So this is in German again, but it's asking people about where they are working. So some of the options are in a private, profit-oriented company or a non-profit, but it could also be in civil service, etc. And the left-hand side is the easy version of the question. So that's sort of simple language, sort of concise language, while on the right-hand side, it's the same question, same answers, but it's always formulated a bit more sort of verbosely and complex. The second question, employee level, here the manipulation was different. So this language was the same, but the question which was asking about sort of the level of responsibility that people had, so whether they were, you know, more on a management level or more doing jobs, tasks according to instructions. For the easy version, this was logically ordered, so increasing level of responsibility, while on the right-hand side, it was not. And similarly for the third one, which was asking about the level of the education, so the degree someone had, the first version, the simple one, was increasing level of degree, so starting with sort of a very basic school degree up to sort of more advanced one, while on the right-hand side, this was not ordered systematically, but randomly. Okay, here's another example. Frauke already showed some of what these mouse movements can actually look like. So people do interact with the page. And then we actually did sort of 2 projects with this. We first obtained these extracted mouse movements from the raw data. Then we used this mousetrap package that in particular Pascal and Felix programmed. Here's a reference for this, but you can also find it online on CRAN and with the documentation here. And this allows you to basically work with these mouse movement trajectories. So you can first maybe resample to have everything recorded on the same frequency, but in particular, you can also extract the certain features that have been seen to be interesting in the past. So you to show in particular also whether there's difficulty with the question. And then for the second part, we wanted to look at the whole trajectory, not just extracted features. And so we also had one version which was time normalized just to have sort of the same number of timestamps for everyone. So for the feature extraction, you can see what kind of features we looked at, time-related ones, total response time, time until the first movement is initiated, etc., flips and X and Y direction, total distance, maximal velocity and acceleration, and as well as hovers, number of hovers, and a total time of hovers, where we needed to define a threshold from where to call a sort of a small pause, a hover. Okay, so yeah, so the goal was here to then detect a respondent's difficulty from the mouse movements. We should keep in mind that actually this is not subjective difficulty, but manipulated difficulty, which is on the one hand a plus because it's not subjective. On the other hand, it can actually also mean that the manipulated question, like the more difficult version, might not have been difficult for everyone. So there might be, you know, sort of the manipulation might not be all that strong potentially. The goal was to classify trajectories into whether they came from the difficult or the non-difficult version of the question, so either complex or simple language or unsorted versus sorted choices. And we had basically two papers looking at this. The first wanted to just see whether with the kind of features that have been looked at before, which are also coded in the mousetrap package, whether we could detect difficulty using gold standard machine learning methods and yeah, demographic variables, which actually didn't turn out to be so important. And then in the second project, we wanted to see whether these extracted features, they are of course things that we think are relevant beforehand. But of course, once we have coded these features, we no longer look at the whole mouse movement. And so the question is there actually more information contained in these mouse movements than the features? And this is also where Frauke and I basically got together. So she's sort of the Paradata expert. I'm more looking at statistical methods, including functional data methods. And so the idea was to use some functional data ideas in order to look at classification of the whole trajectory. So what we did here is to extend some of these methods to trajectories in 2 dimensions on the screen, or it could also be higher dimensional. And these methods are based on distance measures. So you're always trying to come up with suitable ways to describe whether certain mouse movements are similar or dissimilar. And this is coded in what we call distance measures or semi-metrics. And so we came up with suitable ones also that work in these higher dimensional settings and for our kind of data. And then we proposed an ensemble method to do this functional data classification for these kind of trajectories. Okay, so first this gold standard learning method, which can also serve then as a benchmark for the other method, looking at the whole trajectories. We looked at these 3 questions again, and we extracted the features you already saw on the slides, as well as demographic variables. And then we had one further step, which turned out to be quite helpful. That is to look at these features, not just in terms of absolute values. So for example, how long someone was taking to fill out the survey, but rather also to personalize these features. So to say, is what they are doing actually unusual for their usual behavior? And we did this by looking at 8 questions, which we called baseline questions, earlier on in the survey, which were not manipulated. And then we used linear models to basically see what people were typically doing on average at baseline, and then subtracting that from the actual value in a given question. So actually just looking at the deviation from the usual as the relevant feature. And we did something similar also for the screen position, just in case that the answer that someone shows on the screen also had an effect on these features. Say the total distance traveled could be influenced potentially by where the correct answer was on the screen. Then we've had these features into a range of machine learning methods for classification to predict easy or difficult question version, including logic models, decision trees, tree-based random forest, tree-based bagging, tree-based gradient boosting, support vector machines, and neural networks. The idea really being to sort of have a benchmark comparison and see what sort of state-of-the-art methods can do with these features. Okay, then the second method was where we wanted to compare basically whether we could do better compared to these state-of-the-art methods with features extracted. Here we wanted to look at whether we could find more relevant information by looking at the whole mouse movement. And then the idea was to use methods that work with distances. So look at sort of similarity and dissimilarity of trajectories. Once we are looking at distances, we can basically use standard methods, k-nearest neighbors or kernel-based classifiers, just having to sort of come up with suitable distances that work for our kind of trajectory data. And then the second step is to build several of these classifiers potentially that look at different aspects of the data, and then create what's known as a super learner or stacked ensemble, which combine these different classifiers into a sort of a big classifier that hopefully has better predictive performance. Okay, so I said that these classifiers work with what's known as semiometrics, just think distances. So basically trying to see how far away trajectories are from one another. So people do quite different things with the mouse. So it's not so easy to say actually, what is similar, and you have to say in which way similar is meant to be. And so we came up with a whole range of different ways to measure these distances. Some are more standard, like an L2 distance would, for example, just basically look at the point-wise distance at each time point on the screen between two trajectories and then integrate that. But there's also, for example, elastic distances, which try to first align trajectories according to time. So if someone, for example, has a longer initiation time than someone else, then maybe one needs to compress or stretch that first initiation time window in order to align what they're doing afterwards better. So dynamic time warping is one example of such a distance. But then we also looked at others, so we can also look at velocities and acceleration. For example, we looked at fractions of time spent at different areas of the screen, or the sequence of screen areas visited, etc. But we also looked at just regular distances between the features we already extracted for the first project, which of course we thought could still be useful here as well. Okay, so then we can look at the classification tasks. So basically we have a learning sample available, a data set where we know what the label is, so whether this came from the easy or difficult version of the question. And this always means we have a trajectory and a label available, but then we want to predict the class, so easy or difficult, for a new observation, just given their trajectory. Okay, so that would be the setting where later we try and sort of detect difficulty in an ongoing mouse movement, basically. We had these two sort of basic classifiers. The functional KNN was just looking at the k nearest neighbors of the new trajectory in our training sample. So using these distances that we defined beforehand and saying, okay, according to this particular distance, these, say, 5 trajectories in the training sample look somewhat similar. And then predicting the probability to belong to a given class, say easy or difficult, just with the fraction of these trajectories belonging to the easy or difficult setting. And then the class label is just predicted by the majority class, so by the most prevalent class in the neighborhood. Kernel-based classification works similarly, but there we don't build a neighborhood. We just look at sort of the fraction in the whole training data set, but weighted according to how far away these observations are from our new trajectory in terms of the distances we defined. And then the unknown class is again predicted by the highest probability. Okay, so basically now we can define a classifier based on each of the distances we can come up with, but clearly these distances sort of capture different features of the trajectory. Some are looking at the whole trajectory, just looking at sort of integrated square distance, say. Others are looking at very specific features. And so they all capture different information about what the mouse movements are doing. And so the second idea was to combine these into what's known as a stack generalization ensemble. So combine this classifier in a more powerful classifier that collects all the information together. And so how this works is that you have two steps. You first build all of these weak learners, so all of these classifiers using just one distance measure at a time, and tune it using cross-validation. That gives you class probabilities based on each classifier in turn. And then you feed those into a second classifier called a superlearner, which then tries to get a better prediction out of these predicted probabilities from the first step. For the superlearner, you can use different classifiers. We looked at 3 different versions. The first just combines these probabilities in a linear way, building on this paper. And then we also looked at more flexible combinations based on tree-based random forest and boosting. So these are more flexible in terms of like interactions. You can include further covariates such as age and sex here, and also allow for different distances to be relevant for different classes, say. And then finally, we wanted to evaluate the predictive performance out of sample. And so we used nested cross-validation, so tuning all classifiers in the inner loops and then evaluating in the outer loops to still have some out of sample data available. Okay, so some results for these 3 questions. If we extract these features and feed them into machine learning methods, then we see that the nested cross-validated accuracy that we get is somewhat modest. So it's about 0.59 in these 2 cases and 0.65 here. Remembering that random guessing would give you an accuracy of 0.5. This is better than random guessing. So there is a signal in the data, but clearly you can't sort of classify with an accuracy of 90% or more. It's interesting also to look at what methods work best. So we had tree-based gradient boosting or random forest always popping up as the best learning model for the superlearner. And the 3 most important features varied across questions. Remembering that also the manipulation was different. This might not be completely surprising, but some things came up several times. So for example, vertical flips or the total distance or hovers came up more than once. So then we wanted to see whether we could do better by looking at all of these different distances and using those for classification. Here for employment data, you can just see listed downward in terms of performance. The first classifier actually worked best just using response time. So that clearly still is relevant. But then we also saw others working just with the maximal position in Y or X direction, say, hovers, flips, etc. So also these more feature type metrics. But then we also had some others like this Hausdorff one that used, or this L4 one, which used the whole trajectory. For employee level, the most important one actually turned out to be this dynamic time hopping one. So the one looking at distances between the whole trajectory, but first trying to align what people were doing in terms of time. So that's sort of interesting because that's not a distance based on just features. Then we fed those into the ensemble. So we started always with the best performing classifier and then included further ones if they improved the predictive accuracy. And it turned out that we did actually improve the accuracy compared to the just feature-based classifier. So we had slightly better performance here, not tremendously so for this particular question. For the other one, we did see quite a bit of more of an improvement. So here 0.59 was improved to 0.77. So it seems that there is indeed more information contained in the trajectories than just is captured by these features that you can extract beforehand.
Sonia, just to be clear, you have about 5 minutes left, okay?
Perfect.
Thanks.
So I'm about to finish anyway. So to summarize, yeah, so we had basically two papers that are listed here. The first one was just trying to benchmark with existing methods, machine learning methods, and extracting features beforehand from the mouse movements, whether we could predict whether someone had an easy or difficult version of the same question. And we did see that, yes, there is some signal in the data. We also saw that personalization seems to be key. So it's more relevant whether what someone is doing is unusual for their usual behavior rather than the absolute sort of value. But we did also see in the second paper, here's the preprint, that if you try to use the whole mouse movements instead of just extracted features in these ensemble models that we came up with, then that also improves model performance. So you can classify better whether it was the easy or the difficult version. For some questions, the difference was not actually that great. This one was rather small, here a bit more. And then for this question, we saw a huge improvement. So there is definitely more information in these mouse movements than just some few features. And we are still working on several things. So an R package is hopefully coming out soon. But we are also looking at further methods to improve classification. So building on some recent deep learning advances. We want to roll this out in larger data and studies, and then also look more at heterogeneity within sort of the population, because it seems that people are doing different things with the mouse, and that might be interesting to look at. So thanks. Yeah, I'd be happy to take any questions.
Great. Thank you, Sonia. Let's give her a round of applause. Okay, yeah, we have about 5 minutes for questions. So again, I can walk around the room, or if there are people with questions in the chat, we can look at those. So, okay, so no chat right now. Any questions in the room for Sonia? Okay.
My question is, can the algorithm detect from the mouse movement and the time between questions, can detect whether the respondent is actually looking for a job or is trying to procrastinate and try to get the unemployment benefit? Can you tell from analyzing the mouse movement?
There would be an interesting
my
question, which we did not look at. No, we didn't collect that particular, we didn't look at that particular question.
That's interesting. Okay. Other questions for Sonia? Yep. And if you could introduce yourself.
I'm Cindy Ubartes from Statistics Canada. I'm curious to know, like, what's the proportion of people who still answer with a PC or with a laptop using a mouse? Because I know in Canada, we've seen a lot of responses lately when looking at browser information that use smartphones or tablets, and it wouldn't be applicable for them. So are we excluding a large proportion? I've seen some of the numbers at the beginning, but in general, do we think we would exclude a large proportion of our respondents using these types of analysis?
I think Frauke would know the numbers better than I do, but if I remember correctly, the last time we looked at this, there was still a sizable proportion of people. I think it might have been more than 50%, but again, Frauke would be more knowledgeable on that. But we are, in fact, that's not listed here, but we are, in fact, in the second funding period, also looking at other kinds of Paradata, and that would include smartphone users and whether you can still detect then from their interaction with the screen something. This information might, however, be more sparse. That's something we will look at because you are touching the screen, maybe not, like there will be gaps sort of in between because you're not using like touching the screen all the time compared to the mouse, which is where the cursor is always there, at least, even if you don't move it.
Let's do one more question. Yep.
Yeah, Henning Silber from Survey Research Center here. I was wondering, did you compare the measurements with, for instance, assessments with just using response times and how that performed in comparison?
Yeah, so that's basically implicit here. We have here the response time also included, both here as well as in the here sort of the this is basically using response time and other features that are extracted. And if the machine learning method included other features as well, then those were relevant. So I don't have the numbers exactly how response time was doing here in these classifiers, but you can see it here that response time alone was, you know, the number, where's the number, the final number here? So the, you know, you were doing okay with response time, but you were clearly doing better if you use more information in the trajectory. So here it's like 0.68 compared to 0.61, but that's also a setting where response time came up as one, you know, the first important thing. Here it didn't actually even feature in the list. So here other things just did perform better.
Interesting. Okay, thanks. We did have a chat question or two as well, so one sec here.
Yeah, so the first one is, have you just excluded mobile respondents or push respondents to use desktop device? That is the first question. The second one is, what about the difference in screen size between desktop devices? Were you able to identify where was cursor relative to the question taking into account the screen size? If yes, how?
So that's actually something we did not do, but Frauke's team did. So they did resize it. She might be able to answer more about that. But they sort of within this mousetrap, I'm not quite sure whether that's within the mousetrap package or just the pre-processing they did. But they did resize basically the screen to be comparable across the subjects. And the first question, I'm not sure whether I caught that. Did that also refer to certain devices being excluded, like handheld devices, you mean, or?
The third one is, have you just excluded mobile respondents or push respondents to use the desktop devices?
Here we focused on mouse movements. We had a couple of responses also from like handheld devices, but not so many. So we didn't focus on them so much because we had a much smaller data set, but that's something we will look at in the second funding period as well, because clearly that's becoming more relevant as well. So I think that's basically the same question, maybe the first one asked as well.
Okay. All right. Well, let's give Sonia another round of applause. Thank you for being our first remote presenter. So.
Thanks.
Okay, just making sure this popped up. Okay, great. Okay, our next presenter, and I should say before I introduce EPEC, all of the slides are going to be available on the Paradata Workshop website. So we've had those put up this afternoon. So I know many of you are taking pictures, but the slides will be available on the Paradata Workshop site. So just keep that in mind, and we'll remind everybody about that afterwards as well. So. Okay, our next presenter is EPEC Bilgin from the NORC at the University of Chicago. And she's going to be talking about utilization of auxiliary data to identify suboptimal responses in inattentive panelists in a probability-based panel. So, EPEC. Yeah.
Well, thank you. Well, first of all, thank you, Brady, and thank you for the organizers of this wonderful workshop. It started out amazing. So we are going to shift gears a little bit. Go. If you're standing to the side, I think you need to hold the microphone. Oh, not here. Okay, I'll just talk from here. Thank you. I do that in my class as well too. I always have a little microphone here, but so we are going to shift gears to how we are going to utilize Paradata. So it's not just about the quality of the Paradata, but how we use it. And especially with the emergence of probability-based multi-purpose panels, I specifically wanted to discuss several Paradata measures that we all use in multi-purpose online panels. So I'm sure folks like Ari is going to empathize with me. If we only have a nickel for every time we heard the users of online panels about the bogus respondents, professional respondents, satisficers, inattentive panelists. It's definitely a big concern for online panel data users, but just like transparency measures, just like quality measures, unfortunately, there are still yet to be widely accepted industry standards for cleaning online panel data to remove these suboptimal responses from the data, or excluding panelists who chronically provide suboptimal responses. We each do our own thing. While the practice is not as standardized, the findings find that when we exclude this data, it does impact our samples, especially in opt-in panels. So you might say, well, Ipek, this is less of an issue in the probability-based panels than opt-in panels. We should be as more worried about fraudulent or bogus respondents in panels. Yes, that's right. But then there's the other side of the story, right? Those inattentive panelists and satisficers that are more of a concern in probability-based panels. And that's what we are really going to talk about today. And specifically, we are going to discuss identifying these panelists who are chronically providing suboptimal responses to experiment with various interventions. And I also want to mention why this is important, because it does impact measurement error, but it doesn't just impact measurement error, but the error is disproportionately larger within key subgroups who are also hard to reach. These subgroups are, for instance, the low education folks, younger folks. Just to give examples, those folks are harder to reach, but also harder to retain. So they are really, really valuable for us, right? So we don't want to just kick them out of our panels. So that's why it's also very important for us to first identify them, but then do something about them without kicking them out of the panel, such as interventions. And that's where the data, Paradata comes into place, where we are with the identification stage. So here, our study objective, again, I promised a more pragmatic or practical presentation. So I'm going to talk about various interventions that we had done to encourage them to more consistently provide higher quality responses. The question is, do these interventions help overall improve data quality, and which interventions help? But of course, there's this always, unfortunately, yin and yang between measurement error. I don't know if it's more yin and yang, but there's a relationship between measurement error and non-response attrition. So whenever you try to increase and improve data quality with those interventions, there might be the other side of the coin. It might impact non-response and attrition, and I'm going to talk a little bit about how the relationship between the two. But so do they have an impact on non-response or attritions of these various interventions? And then the more important question is, which interventions improve data quality among subgroups, because we see this measurement error more in these subgroups. So what did we do? We conducted experiments in the AMER-Speak panel. So AMER-Speak panel is NORC's multi-purpose probability-based, mostly online panel. And we like it when you use it a lot because of its efficiency from both time and cost perspective. So you already are familiar with many measures of suboptimal response. Most are identified using Paradata, such as straight lining, skipping, speeding, extreme responses to numeric, or gibberish or AI responses to text open-ended questions. There are also the other two, trap questions and consistency checks, that within AMER-Speak we don't necessarily like using, just because trap questions and consistency checks are so obvious in questionnaires that could turn off our panelists. And we are really concerned about the relationship between us and the panelists, and we don't want to do anything to turn them off, such as using either trap questions or repetitive repetitive questions, which are consistency checks. So Amir Speak's response to suboptimal behavior has been twofold. First, if a panelist is flagged as giving a suboptimal response due to straight lining, skipping, and speeding, those are the three measures we use and we capture it through Paradata. Such data is cleaned from the survey. And second, we reach out to respondents who chronically provide suboptimal responses. This study focuses on the latter, these interventions. So what have we done? We identified panelists who chronically exhibit suboptimal survey-taking behavior since they joined the panel. Again, there are no widely accepted standardized standards, but with how everybody is monitoring and flagging these behaviors, but we did flag panelists who exhibit suboptimal responses due to straight lining, skipping, and speeding. And we just flagged this as 0 and 1. So it was a dichotomous measure per survey. And we did identify the straight liners using the completion rate. So if the completion rates was an outlier or an implausible value, and we use quartiles. So if you are in the highest quartile, same with skipping and speeding, straight lining is less common, speeding is more common, so that's why we use the quartile system. So if you do multiple of these behaviors in a survey, you still get a 1. So then we looked at the data at the panelist level, right? So based on all the surveys they take, each panelist gets an average score. We call this SSS score because it's the skipper, the straight liners, and the speeders. So our SSS score is our data quality score. The higher of the score, the lower data quality you have. So from this average score, we identified panelists who chronically exhibit these behaviors using a cutoff percent. So again, we used the quartile information, we used the upper quartile, and then we labeled them as chronic panelists who chronically exhibit suboptimal survey-taking behaviors. So notable demographics that exhibited this behavior is low education, less than high school. Well, this is very standard with when you look at the Satisfizer literature, you see the low education. We also saw this among younger, the low income, male, and then we also saw it within device type smartphone, but this is on us, right? Sometimes the behaviors of respondents, the suboptimal behaviors are generally on us because of for instance, the mobile optimization that might not be optimal. So now the more fun part, here are the experiments. So first, this is just a very simple experiment. We have the control group, and then the treatment one is we send an email contact describing the importance of good data, how a panelist can help, and how much we value them as panelists. So it's just one email. We could have done even more, right? We could have sent them texts. We could have done more real life warnings. So we just sent one warning email, but we were also concerned about the implications. Remember what I mentioned about like attrition and non-response? We didn't want to turn off our panelists by giving them these warning emails. So we want to be a bit subtle in our experiments. And then we may need to do further experiments, for instance, these real-time warnings. But we wanted to see, let's see what happens if we provide just a subtle warning. Even more subtle is the second treatment group. We sent them a short questionnaire subtly asking about the reason of their behavior, learn more about their survey-taking behavior. Some questions included, what do they think about the number of survey requests received? Where do they complete survey in general? When do they complete the survey? Do they multitask when they do these surveys? Is there any aspect of panelist experience that we could improve? What we could do to improve their experience? so on and so. What are the obstacles for them to respond carefully to surveys? So it wasn't necessarily, hey, you are doing this behavior, but it was more about what can we do to fix this? So there's an issue. So versus an email was less subtle. We just provided that, how they can help and how they can help increase the quality of their responses. So then we examined the change in their suboptimal responses and completion rates. And we also looked at attrition before and after interventions. I didn't include attrition here because we didn't see like this huge drops after the interventions. Like it didn't necessarily turn them off drastically. So right now I'm just presenting suboptimal responses and completion rates. So we looked into before intervention and after intervention for all these groups. So now more the fun part here. So just to orient you with the slide, this is 0 point, and then you see a negative value. That means that this is the difference between mean SSS value before intervention minus mean SSS after intervention. So it is negative. That means that there is an overall improvement in data quality. So they are straight lining, skipping, and speeding behaviors decrease over time. And regardless on which treatment group you are in, your data quality gets better. And that's because of attrition, because our better respondents remain in the panel longer. The bad, let's say bad respondents or bad panelists tend to attrit. So that's why that's also, it's just manifesting itself here. But regardless here, what I want to show you guys here is the difference of differences. So the gray line is the control group, the NORC orange is the email, and then the purple is survey. So what we have seen here is the email intervention communication actually significantly improved data quality. It significantly decreased that SSS value that we measured data quality with. And but then when we look at this behavior among different subgroups, so we see a lot more of this data quality issue with our younger panelists. So that's why you may see, well, it looks like the difference of differences looks a bit even more in other measures. But the reason that's significant among 18 to 34 is because we have a lot more data in that cell, because we have a lot more panelists who chronically provide low data quality. So here, what we see is email actually helps significantly in comparison to the control group. The survey actually seemed to help too, especially when we look at the 18 to 34, but we didn't see that it being significant. And when you look at the overall chart, what you see here is, other than that 50 to 64 age group, overall, both the email and the survey actually does help. So you see, went to improve data quality, which was very encouraging to us. And again, we looked at education. You see some significances with the low educated group. That's because, again, more cell sizes in that group, because more behaviors, these type of behaviors happen in that group. But again, what we have seen is both the email and the survey significantly improve data quality. So our interventions seem to work within these groups. With the other groups, we don't necessarily see much of a difference, maybe a little bit with the high school, graduated from high school, you see a little bit of an improvement. But when you look at postgrad, you see some. I mean, overall, you see in general an improvement in data quality, but most of it you see with the lower educated. And then when we look at the race ethnicity groups, we see that our email actually was the most effective among Black and African American folks. We also see improvement in among Hispanic groups as well. And I specifically want to, versus with Asian groups, the interventions didn't really help as much. So there's some tailoring methodology that might, that this really signals to as well. And I really, the education, the income, the minorities, the age, these are really important for us. But again, as I mentioned, these are very valuable groups, the low income, minority, low education, younger, because we really, they attrit in the higher rates. So we want to make sure that we get the best data as possible from them. And we keep adding more of them during recruitment, but we also want to understand their survey taking behavior. And then when we look at the urban-rural classification, we see that our interventions, which was interestingly enough, were more effective among rural folks. So you might ask, all right, well, your interventions work, that's great. It improved data quality somewhat, especially in some groups significantly. So, but what happens their completion rate? So you told us these interventions doesn't necessarily impact attrition. Attrition happens over time. You don't see these drastic attritions. But let's look at the completion rates. Are our interventions turning off some of our panelists and decreasing their completion rates? So what we have seen is with the survey, it doesn't, but with the email, it slightly does, but we don't really see that difference is not significant, but there is a decline. So this, so in general, again, you see overall improvement in completion rate over time in all groups, but that's again, somewhat due to attrition. But again, this improvement is just smaller for the email intervention group. But again, not statistically significant. So when we look at age too, so in the previous graphs, when you look at the lower values were better here in this graph because it's completion rate, the lower values are worse. So we see that orange line is mostly among our younger groups in the lower scale. So we see that it does slightly decrease the completion rate. So the interventions are helpful, but it not significantly, but it does turn off a little some of our panelists. Same with education, not necessarily significant. One good news is that it didn't impact less than high school completion rates, which we were really happy about. Nor the high school graduates, versus it did impact for some college, versus the other ones, it really didn't have much of an impact. Here, with the race ethnicity groups, we also don't see much differences, maybe with a little bit with the other group. Lastly, with the rural-urban, we see that we see more within the rural group that the email intervention may be decreasing completion rate. So what does all that mean? So this is, first of all, an example of using Paradata to monitor and increase data quality in online panels. Again, the use of Paradata in widely asked questions. We get this question a lot. The data quality is a concern for our panel users. So we have now our approach is more reliance on interventions and less reliance on post-data adjustment strategies. And then, as I mentioned, to wrap up, email intervention had a positive impact on data quality. We see significant overall decrease in some suboptimal responses. It didn't have impact on attrition, and it did impact non-response. We see slight increase in non-response. So improvement in data quality among key subgroups, more susceptible to suboptimal behaviors, which was a big win for us. But what are the potential next steps? So now we need to really think through. David Dudman and I are always thinking through how can we standardize systems when it comes to online panels. Like all different panels, probability-based, specifically probability-based multi-purpose panels, we do our own thing. Can we have a standardized data quality systems, not just how we measure it, but also how we improve the data quality, and how we also detect folks, panelists who chronically have lower data quality. So we want to tweak the precision in what we do. So we could use maybe auxiliary data, other measures, gold benchmarks to see if who we are actually labeling as chronic lower data quality, just to see if we are labeling them in a precise manner, or do we need to increase? We have been a bit conservative about them because we weren't sure how those interventions was going to impact. So what's the precision? The other part is, what is going to be the long-term effects of Paradata-driven interventions on data quality, retention, and response? And lastly, the use of Paradata and generative AI to implement interventions in real time. Do we want to give warnings to our panelists? Hey, you are speeding too much. Are you paying attention? Hey, are you multitasking? Oh, we see that you skipped these questions. Are there problems with this? Can you tell us? So these are some implementations that we could do. But before we do that, we wanted to make sure that these do not annoy our panelists. So more data and more studies to come. With that, I am done.
Great. Thank you, Ipek. Questions in the room? Yeah, we'll go in the back here first.
Yes, thank you for a very interesting talk. You mentioned amongst the 3S cohort, low income, low education, the younger age, and also, but you also mentioned use of iPhone. And to what extent is iPhone an independent variable? Because seemingly, and the other thing, your email intervention, I was wondering if you include the possibility of sending text messages instead of email, because a lot of people who, younger people who live on the iPhone don't really use email as much as they text. So just some couple of comments.
Very, very good questions. Number one, with smartphone, yes, we did control for smartphone in our models. So our dependent variables were this 3S measures and then a completion rate. So we did use one of the some of the variables that are in our control. We did control for them. One was device type. Your second point is very interesting because we did think about, should we send email, text, and then we also have a portal. We were going to have a warning in the portal too. But what we were really, really concerned about is, are they going to think that we are monitoring them? So would that impact, would that turn them off and say, forget about this? These people are like very, very, you know, we didn't want them to think that we were really being too A-type. So what we did instead is we started subtle, and email was the most subtle way for us to go, because text is really, I think our next step is actually doing text or real-time interventions, as well as including maybe a warning in our portal. And very good point.
Okay, here's one. Hi, thanks very much. That was very interesting. Just a question on, did you track the time between sending the email and the person actually completing the interview, and if that had an impact on sort of how that message resonated with them?
Another good question. With completion rates, we did look at because we needed some data, but our pre-intervention completion rates was previous 6 months, and then our post was post 6 months. So that one, we didn't necessarily, by the time it's 6 months, they probably, to your point, forget about that email. Versus, again, with the SSS measures, we did need the data, right? We do need this big data, because we don't want to just observe their behavior with just one survey. We wanted to understand the long-term effect. But now I think our next step is really looking into in the timeline, where what happens we send a text, what happens we show it in the portal, what happens in the email, and really look in the real time how that both short-term and long-term impact the data. Again, another very good point.
Okay, we had some chat questions too.
Yes, like 5 questions. The first one is, do you think that the effect of email survey intervention will last? In the same chat, for how long do you expect suboptimal respondents to provide better quality before coming back to suboptimal response patterns? And the last one, are you going to follow the same respondents and their response quality?
Yeah, so I don't think it's going to last. I think people are going to forget about it. Oh, yeah, go ahead.
No, this was my exact question. How long it lasts, and then when do they sort of go back to behavior as the prior point, kind of regress, right?
Yeah, and we are going to be following these folks as well. So I think this makes me think, these are really good questions. This makes me think, okay, we really need to look at those SSS measures, like through, what happens within the 5 days, 10 days, 30 days. And that's definitely could go into a paper potentially here. But I don't think it's going to last. I think we do need to, and knowing this from more experience, right? Whenever we do these interventions, they have to be continuous for it to last. And again, I think email is very subtle. So but with us, it's also again, like the issue of, what if we do too much? What's that sweet spot? And we still haven't gotten that sweet spot, right? Like, is 3 texts a sweet spot? Is like sending once every 6 months? Is sending every, once in 3 months? So these are some of the things that we still need to explore as well. And I'll definitely, so the team who work with me, we have a meeting next Monday. I'll bring these points up to them. These are really, really helpful, actually.
Okay, how did you operationalize speeding? When was someone seen as a speeder, and did you define this on a question, page, survey, or panel level?
Survey level. We did measure it. So every survey, we just flagged whether they are a speeder or a straight liner or a skipper. And it was just a dichotomous measure. Of course, we could probably use a lot more complex measures too, but it was more about, we looked into the quartile. So what's the average, what's the 75% of people, so we looked into that quartile, and we looked at the highest quartile, and we flagged the people in the highest quartile. So again, just survey level, and it was a dichotomous variable.
Okay, and the last one, did you only experiment with the panelists that had a high SSS, or with all panelists?
Just with only with the high SSS panelists. So with the chronically lower data quality folks. Just because, we don't want to, our good panelists, we don't want to just tell them, hey, your data quality needs improvement, right? So we just want to make sure that we only target those we have an issue with.
Okay, one more and then we'll take a break here.
Oh, thank you. I was just, this is actually sort of related to one of the questions that came up in the chat, and it's something I've been kind of trying to think through. In your measure of speeding, do you account at all for the possibility that people might naturally get faster at responding to surveys the longer they're on a panel for legitimate reasons?
Yeah, no, that's like a part of panel conditioning that we need to take into account, right? No, that's also a very good point. And, we did control for panel tenure in our models, so that should potentially take care of that. But I think if you have any other suggestion, Mickey, let's definitely talk. But tenure was one of the control variables.
Okay, great. Well, thanks, EPAC. Let's give a round of applause again. Okay, so we're going to take a break until about 3 o'clock. So those of you who are here at ISR, there's refreshments and snacks in the back of the room, so please help yourselves. And then we'll get started again at 3 o'clock with a couple more in-person presentations. Okay, thank you. All right, I think we're going to go ahead with our 3 o'clock presentation. So if everybody would like to take their seats here in ISR. Okay, So our next presenter is Mickey Jackson from SSRS. We're actually going to have back-to-back SSRS presentations because they're doing a lot of really good stuff there. Again, these slides are all going to be available on the website, so feel free to take a look if you'd like to follow along or download the slides. But Mickey is talking about calling the right cases, leveraging Paradata and auxiliary data to improve the efficiency of outbound CADI follow-up and address-based samples. So Mickey, the floor is yours.
Thank you. Another mouthful of a title there. Basically, what I'm going to be talking about is the use of Paradata for adaptive survey designs. And I'll mention some of the results that I'll share today have actually already been written up. They were part of the this year's JSSAM special issue on mixed mode designs. But some of what I'll be sharing, the second half of the analysis, is actually new results that I don't think we've presented anywhere to date. To start out, I just want to say we're going to be using a lot of data today from the California Health Interview Survey, or CHIS, which is sponsored by the Center for Health Policy Research over at UCLA. We're very appreciative that they've allowed us to present these results, and of course want to emphasize that anything I say is my opinion alone. So as I said, I'm going to be talking about some work that we've been doing to integrate adaptive survey designs into CHIS, which is of course an effort that has relied heavily on Paradata. Broadly, adaptive design refers to the differential targeting of data collection interventions based on some observed or modeled characteristics of the sample units. And I think in thinking about the role of different types of data, it's useful to make a distinction between static adaptive designs and dynamic designs. So in static designs, the interventions are kind of entirely pre-allocated before the start of data collection. So there's not really a direct role for Paradata in these. You rely on whatever auxiliary data you have prior to the start of data collection. But in dynamic adaptive designs, you're making decisions about how to allocate these interventions in real time during data collection. So these types of designs are where Paradata tends to play a very large role. So I'll start with some background on CHIS. It's a very large-scale annual study of the California household population that measures various items related to healthcare access and outcomes. Since 2019, it has primarily relied on an address-based sample frame. There's an RDD supplement, but ABS is the primary frame and what I'm going to be focusing on today. The sample design is quite complicated, but there are two features that are particularly salient for the analysis that we'll do here, so I'll highlight those. The first is that it's in the field throughout the year. The sample is released in 25 randomized replicates from about February through August, I think, of each year. The other thing I'll note is that although this is an annual study, it is designed specifically to allow the pooling of data. California is a big state with a lot of small populations that people are interested in analyzing. So we designed this in such a way that the sample design and data collection procedures remain largely constant for each pairing of an even or odd year so that people can pool the data and look at small groups. So as I mentioned, 25 waves a year. This is basically what each of those waves look like. There is a mail push to web phase at which each address can receive up to 4 mailings. Those who don't respond to those mailings then transition to the outbound CADI phase. Now, because this is an address-based sample, we rely on phone matching. So this phase applies to the roughly 70% of addresses who have a phone number matched by the sample vendor. And historically, the protocol for CHIS has been that everybody gets up to 6 calls before we give up and call them a non-respondent. So that CADI phase is where the adaptive design principles have started to be integrated into CHIS. So we started doing this midway through the 2022 collection. We'd experienced some cost overruns in the CADI phase, so we needed to find a way to reduce the amount of outbound dialing while minimizing the impact on response rates and sample composition. So we often think about adaptive designs as solving an implicit optimization problem. So here, we're really trying to optimize on cost, but subject to constraints on sample productivity and non-response bias. So this is a visual depiction of how the sort of full adaptive design that we're currently using in CHIS works. We have two intervention points. One of those takes place before dialing begins for a given wave. So at the end of the push to web phase. And the result of that intervention point is that some cases have their max number of outbound calling attempts set to just one, while the remainder are allowed to continue past one call. Those that do continue then reach the second intervention point, which takes place after call 3. And at this intervention point, again, we have some cases who then get retired at that point, with the remainder allowed to continue to the max of 6 calls. So let me talk in more detail about each of these. The first intervention, what I'll call the pre-dialing intervention, takes place after the push to web phase. And so what we do for each wave is that we run a random forest model where the dependent variable is the interim response status as of that point in data collection. Now, for this intervention, the predictors in this model are all auxiliary variables. They are variables that are matched from external consumer and voter files that reflect demographic information and other kind of semi-substantive data about the persons at the sampled address. So we're not using Paradata as predictors in these models. We are using data that tries to measure the characteristics of who lives at the address. And so after estimating this model, we assign a response propensity score to every active record at that point in data collection. So the way to think about this response propensity score, it's the same kind of response propensity score that you would use in weighting. The higher the score assigned from this model, essentially the higher the score, the more that case's unique combination of characteristics are overrepresented as of that point in collection. So people who are from subgroups that had relatively high response rates to the mailings are going to have a relatively high response propensity score from these models. And so what we do is we set the max number of calls to 1 for cases whose score is above a certain cut point. So the idea at this point is that we're trying to limit the amount of dialing that we do for subgroups that did particularly well in the push to web phase and prioritize our dialing resources towards those who are underrepresented from the mailing. So trying to reduce dialing in a way that hopefully reduces observable non-response bias. So again, those who survive that intervention, as it were, eventually reach call 3, which is our second intervention point. Now at call 3, we again use a response propensity model, but the structure of the model is different in kind of a subtle but important way. So what we're doing at the call 3 intervention is we are now stopping dialing if the response propensity score is below a certain point. And so what these models are predicting is the probability of completing this is the probability of completing the survey at one of the final 3 calls, conditional on not having responded yet as of the 3rd call. So these models are not being rerun on the active sample. These are pre-trained models that were trained on an earlier CHIS wave that did not include the adaptive design. And in these models, the most important predictors are Paradata variables from the first 3 calls, specifically the outcome codes and the duration of each of those 3 calls. So the intuition here is that we are using the outcomes of the first 3 calls to predict how productive it's likely to be to continue dialing those cases and retiring the ones that we just don't think are worth dialing anymore. Now, I will mention, although Paradata is the real driver of these models, we do sort of implicitly incorporate some auxiliary data into this intervention point by essentially varying the cut point that we use to retire cases depending on the sampling strata. So for strata where historically we've had a harder time getting completes, we use a more conservative cutoff. We don't retire as many cases. For those where we know we're going to reach our targets, we're much more aggressive and we retire all but the highest response propensity cases. So this is just a summary of how those 2 intervention points differ. The pre-dialing intervention is modeling what we might call retrospective response propensity. How likely were cases that look like each of these cases to respond to the push to web phase? So for this intervention, the Paradata enters into the model as the dependent variable in the form of the interim response status, but the predictors are substantive variables, or at least variables that are trying to get at substantive characteristics. On the other hand, in this mid-dialing intervention, we're now modeling what we might call prospective response propensity. How likely are they to respond to the next 3 calls, conditional on not having responded to the first 3? So this is where Paradata enters the models as predictors, not just the dependent variable. Now, because we needed to achieve a certain amount of cost savings, we did not roll out this adaptive design as a randomized experiment. But what is helpful for evaluating its impact is that it was rolled out in a phased manner. So the call 3 intervention was actually rolled out first, about midway through CHIS 2022. The pre-dialing intervention was then added towards the end of CHIS 2023. So I'll start with the evaluation of the call 3 intervention, which is also what's discussed in the paper. Now, again, we didn't do this as a randomized experiment, but the phased rollout actually does provide a decent setup for a quasi-experimental methodology called difference in difference analysis. So the first difference here comes from that phased rollout. What we're going to do here is we're going to call the CHIS 2021 waves the untreated waves. In CHIS 2021, we weren't using the adaptive design, but again, because of our pooled design, the other aspects of the design were quite similar to CHIS 2022. So we're going to call that the untreated wave and use it as the control. Now in 2022, the adaptive design was launched around the time that outbound dialing started for wave 9. So waves 9 through 25, we're going to call the fully treated waves because everybody who got to the 3rd call would have encountered the adaptive design in these waves. Waves 1 through 8, we're going to call partially treated. These started outbound dialing before we were using the adaptive design, but there were some records that had not yet reached the 3rd call. So in these waves, some but not all records encountered the adaptive design. So that's the first difference in the difference in difference analysis. The second one comes from the fact that the intervention point occurred at the 3rd call, which means by definition, it could not affect any outcomes as of call 3. Any impact would only show up on outcomes that include the final 3 calls. So what we'll do is we will essentially compare the untreated and treated waves with respect to the incremental impact of calls 4 through 6. Now, for this difference in difference estimator to have a causal interpretation, essentially we have to assume that in the absence of the adaptive design, the incremental effect of the final 3 calls would have been the same between the treated and untreated waves, which is called the parallel trends assumption in the difference in difference lingo. So that's the intuition. There's a lot more detail about this in the paper, including the regression specification that we use to do statistical testing with this methodology. But it's also nice because this type of analysis is very easy to plot. So what we are looking at here is the cumulative completion rate to CHIS at 3 points in the collection. So the first point is before we do any dialing, so as of the end of the push to web phase. The second point is after the first 3 calls, and then the third point is the final rate after all dialing is completed. So the first thing to note here that's kind of nice is the incremental effect of the first 3 calls is pretty similar in all 3 of these samples, which lends some amount of plausibility to that parallel trends assumption. And then you can see that we've got a nice bend in the curve for the second half of dialing, but only for the fully treated waves, which is a nice thing that we like to see in a difference in difference analysis. So what this tells us is that the incremental effect of the second half of dialing was about 0.3 percentage points lower in the fully treated CHIS 2022 waves. So that's our estimate of the effect of the adaptive design on the final completion rate. Now considering the reduction in dialing that this achieved, we considered this to be an acceptably small decrease in the final completion rate. Your mileage may vary, but it met the needs of, it met what we were hoping to see for this project. So now we'll turn to sample composition. So what you see here is, these charts are all similar. This is the cumulative prevalence of various subgroups for which we have sample size targets in CHIS as of the same 3 points in data collection. Now, when we do the statistical testing using the regression form of the difference in difference analysis, there are two subgroups where we see statistically significant changes in their prevalence. There's apparently a statistically significant improvement in the prevalence of African Americans among respondents and a decrease in the prevalence of Asian language completes. However, when we look at these results more closely, we're a little skeptical that this is actually attributable to the adaptive design. What's strange here is that the significant effect only appears for the partially treated waves, whereas if it was attributable to the adaptive design, we'd expect it to show up and be larger in the fully treated waves, like we saw for the effect on the completion rate. So what we think is happening here is that the parallel trends assumption probably just isn't met for these particular outcomes. If you look at these graphs, you can see that for these two outcomes, the incremental effects of the first three calls are not totally consistent between the treated and the untreated waves. So it's possible that what's showing up as a treatment effect here is really more of just a reversion to the mean or something like that. So when it comes to this mid-call adaptive design, it's tough to say much about the impact on sample composition because the parallel trends assumption doesn't seem to hold for all of these outcomes. We generally don't think that there's strong evidence of a meaningful impact on sample composition from this three-call design. So now we'll turn to that pre-dial intervention, which again, during the period that I was analyzing just now, the pre-dial intervention wasn't operational at all. This was rolled out midway through CHIS 2023. So we've got a similar difference in difference setup here. Here, we're not going back to CHIS 2022 as our control wave. We're just going to use the earlier waves of CHIS 2023 as our control waves. That's basically to avoid any confounding by the three-call version of the adaptive design. So the call 3 intervention was operational throughout CHIS 2023. So this allows us to look at the incremental effect of that additional intervention. And then, similar to the previous analysis, we're going to exploit the fact that, because nothing would have changed until after the first call, we can assume that any effect of the adaptive design would show up in the incremental effects of calls 2 through 6. So again, starting with the completion rate as our outcome for this outcome, we again see that the parallel trends assumption looks pretty plausible. And we actually are not able to detect any significant decrease in the completion rate as a result of the pre-dialing intervention. The incremental effect of calls 2 through 6 is about 0.2 percentage points lower in the treated waves of CHIS 2023, but not, at least at this point, that's not a statistically significant result. So then looking at sample composition, again, these are kind of a mess. It's clear that for many of these, the parallel trends assumption that's critical to this difference in difference analysis isn't really holding. Interestingly, there are, again, two demographics where the regressions come up as statistically significant. And so here we're looking at, we do see what appears to be a significant improvement in the effectiveness of calls 2 through 6 at bringing in African-American respondents and Spanish language respondents. For these, the parallel trends assumption looks a little bit more plausible. The effect of the first call is pretty constant between the treated and the untreated waves, and then we see that the curve bends upward for the treated waves for the last set of calls. So perhaps a little bit more plausible to attribute these changes to the adaptive design. But again, this all rests on that parallel trends assumption. So to sum up some takeaways here, generally we're happy with how this worked out. We were able to substantially reduce the total volume of outbound dialing that is needed for CHIS, which is meaningful to us because CHIS has a gigantic sample, so the costs of dialing are not inconsiderable, and the reduction we were able to achieve, had meaningful, enabled us to stay within the budget for the project. And again, in our judgment, the impact that we saw on sample productivity was minimal enough that we were willing to tolerate it. I think a really important point to highlight here is the different roles played by Paradata versus auxiliary data in the models that we used for each of these interventions. Nominally, these were both response propensity models, but they were doing different things and sort of implicitly optimizing on different criteria. So in the pre-dialing intervention, what we were doing was trying to identify substantive subgroups that were overrepresented as a result of the push to web phase and reduce dialing for them. So this was more of a bias model than a response propensity model, and it made sense to use substantive predictors rather than Paradata. On the other hand, once we got to call 3, at that point, we were just trying to predict how productive it was to keep dialing those cases. So it made much more sense for those models to include the call level Paradata that we had access to. This is a point that Andy Pachev and his co-authors highlighted in a JSSAM paper that came out a few years ago that I think is really important and certainly shaped my thinking about this. That when we're building these models for the purpose of adaptive designs, it's important to not just blindly optimize for predictive accuracy, but to really think about what we're trying to do with our intervention decisions and choose the predictors that go into those models accordingly. Certainly, if we're trying to optimize for sample productivity, Paradata is very important and appropriate to include in these models. That's not necessarily the case if we're trying to optimize on bias. There we want the predictors to be variables that are correlated with whatever outcomes we're trying to optimize on. The other thing I'll mention more on an operational level is, this was sort of easy. This was easy enough to conceptualize. It was not necessarily easy to implement, particularly that mid-call intervention that relies so heavily on Paradata and where these models are being scored multiple times per week as cases reach the third call. It's obviously in that situation, for that to be doable, it's really, really important that the inputs to that model, the Paradata from those first 3 calls, be standardized and be measured in a consistent way. So this took a lot of work with our call center and our data processing team to make sure that disposition codes were being assigned consistently and that duration was being consistently measured to make sure that what these models were actually outputting was meaningful. So I think that's sort of not the downside, but certainly the challenge of using Paradata in these models is that it's not just the methods people who need to be on board. It's the call center people and the data processing people to make sure that our models aren't just spitting out junk. So with that, if you're interested in hearing more, again, the top reference here is the paper that's already been published about this that covers the mid-call design. I'm sure at some point we'll write up the pre-dialing intervention. And I'm happy to take any questions. Thank you.
Excellent. Thanks, Mickey. Questions, Charlie? Yep.
So in thinking about strategizing for calls in a telephone survey, one question is how much to call, which is what you've emphasized. The other is when to call. And I'm kind of wondering, first of all, did you take account of, like when you did the second node, did you take account of when the calls 1 through 3 were made unsuccessfully? Was that part of the Paradata? And if so, was the timing of those calls randomized or the convenience? Like, talk about the timing, just generally talk about the timing of the calls.
Absolutely, and this actually kind of relates to the last point I made. Currently, we are not accounting for that in these models. I agree that that's a very important frontier. And part of that is we don't have a ton of visibility into how the call center prioritizes, how the call center decides when to call people. They have kind of their own rules that are driven by various operational needs. We are trying to understand that better and to collect better Paradata about that so that we can incorporate that into these types of decisions. we're not quite there yet, but I absolutely agree that that's important.
Just quick follow-up. I love that question because I think we can learn a lot, and that I'm familiar with that challenge. But on something you said at the very beginning of the talk sort of stuck with me the whole time, that you said it's like, okay, well, past 3 calls, we think it's not worth it, you know, and the worth it, I guess, is capturing the effort you make in trying to keep those numbers in the pipeline given their realization rate. Is there any signal that you would have on their substantive outcomes? Like, it could be worth it for some
Sure.
cases because they're just very different than everybody else. Is there any signal that you have in your data?
No, that's a really good question. And yes, you're right. The sort of what was sort of implicit in saying it's not worth it is we don't think we're going to get them even if we do call them. It's difficult to kind of look at that just because we didn't do this as a randomized experiment. We did look a little bit, you know, when we were building these models, we looked a little bit at sort of, you know, in the 2021 data that we used to build these models, we kind of tried to simulate, well, for the people who did respond after the first, after the first 3 calls, you know, if we pretend that they didn't respond and delete them, you know, how much does this change the outcomes we're optimizing on? And you know, there was a lot of back and forth with the sponsor and simulating different scenarios to arrive at something that we were comfortable with. Because it wasn't done as an experiment, a lot of that was just based on those simulations, but we did consider that as we were building the models and deciding on those cut points.
Can I also add that the stratification the stratification that we use to change the cut points is both predicted based on, you know, frame characteristics and things, and geographic, because the geographic strata in California are very correlated with the health outcomes that are being measured in the survey. And so there are some geographic strata that we're very, very conservative about cutting off. And this really was like, this is like hundreds and hundreds of thousands of dials, you know, that we were just trying to like, right? So to the extent that those strata are correlated with the outcomes, it's included in the process.
Okay, we had a couple of chat questions too, so.
Just one question. What is implied by Paradata standardization on the slide with conclusions? Was any benchmark used for standardization?
I'm sorry, could you say it? Was any...
What is implied by Paradata standardization on the slide with conclusions?
Oh, that was basically just making sure that, like, you know, because we were using models that were built on 2021 data to predict outcomes for 2022 and onward data, we needed to make sure that, like, a particular code meant the same thing in 2022 that it did in 2021, which wasn't always for this because this had been kind of a long-standing collection, and this was the first time we had done anything like this. That wasn't always the case. So that's what I mean by standardization, is just making sure that literally the same value of a variable means the same thing in both years.
When situation warrants that you needed to make additional call, then the additional call is spent in how many days? The same hour or over several days? That's my question.
This is sort of where we don't have as much visibility as we would like into how these decisions are made. It usually takes. I mean, these waves are in the field for months. So there are some cases where, like, the 6 calls take place over the span of weeks or even more than a month. There are some cases that get where they're much more compressed. So it varies a lot depending on what the call center is prioritizing at a given point.
Okay, maybe one more question. Yep, in the back.
Yes, just wondering if the results varied with the age cohort of the respondents and also whether they were using a cell phone or a landline, because in California, there are still a lot of areas that don't have reliable cell service, and a lot of people use landlines. Yeah.
Yeah, that's a very good question. I don't think we've disaggregated. I mean, so the type of number is a predictor in these models. So whether it's a cell phone or a landline is a predictor. So in that sense, we are kind of accounting for potential differences in how this Paradata might predict ultimate response based on whether it's a cell phone or a landline. But I don't think we've disaggregated the results by type of number. That would be interesting.
Okay. All right. Well, thanks, Mickey, again for good presentation. The mouse has disappeared. There we go. Okay, cool. Our next presenter is Cameron McPhee, also at SSRS, where she is the chief methodologist, and she'll be talking about understanding and improving panelist retention and data quality through the use of extended survey history data. So, Cameron.
Thanks. This is the mic that I'm required to stand in front of? Okay. Hi. I want to apologize in advance if there are any typos. I think this may be the top of my procrastination. I was very sick last week, and so I did not get these done as early as I would have liked, which is also why they're not going to be as pretty as Mickey's, who got them through our lovely process at SSRS, but hopefully useful and a nice follow-up to EPEC's talk. So I'm going to be talking a little bit about our panel, our SSRS probability panel, and we have what we're calling a survey history database, which is sort of an aggregated set of data about panelists over time, as well as the studies that they are being asked to participate in over time. And I'm going to talk a little bit about that data. So, probability panels, as we know, offer affordable, more statistically sound solutions compared to the non-prob space for survey research. But we have a lot of questions still. We get a lot of questions, as the last meeting I was at last week. How many surveys should we be sending a panelist in a given time period before they get sick of us? Or how long do we wait between surveys? Is there some optimal period of time between surveys that we should wait for? Do panelists get conditioned and pay less attention over time, like EPEC was talking about? Do they start getting complacent? Do they start speeding? Or do they just become accustomed to taking the survey and just get faster at it? Will panelists stop responding if you ask them about particular topics? Are panelists sensitive to certain politically charged topics or really boring topics or repetitive topics? Is that going to change their behavior over time? And, how do you know when they're gone? So luckily, right, when we operationalize these panels well, which I think many of us are learning to do, we have a lot of Paradata. We have a lot of different types of Paradata on panels, and EPEC talked some about this. So we have what I'm calling cumulative panel level data. So, right, this is for any given panelist, how long have they been on the panel? How many times have they been invited to different surveys? How often do they get invited to surveys over time? What's the average? What's the periodicity of it? What's the total burden that they're getting? Are the surveys they're being invited to particularly long or not so long that you can invite them over and over and over again? We have study level data. So we have the length of the actual surveys that they're being asked to participate in. We have survey topics. These probability panels like ours, we are a client-focused business. So we get clients asking about a large variety of topics, sometimes in the same survey, more often between surveys. What's the study population? Is it a Gen Pop survey, 18 plus adults, or are we just going after, mothers of 3 to 5-year-olds? And are we having to screen out a lot of panelists because we have a lot of data about our panelists. We don't know everything about our panelists. So are panelists getting screened out when they're being invited to surveys or not? Then we have sort of time-based, sort of fixed Paradata. Have they retained the retention, the attrition? Have they left the panel? Have they stayed on the panel? And also their panelist satisfaction, both over time and on average. And then study level respondent data for any given survey. Did they respond? And then data quality indicators like Ipek was talking about, satisficing indicators, speeding indicators, trap fail questions, things like that. So this is all of the Paradata, a lot of the Paradata that we collect. There's probably more that I didn't put on this slide. But it's fuel for great analysis if, as Frauke pointed out, it's useful. So today I'm just going to sort of explore, this is like my first exploration into some of this Paradata from our panel, and I'm going to look at the ways that this Paradata can be used to just better understand the experiences that our panelists are having. Are there correlates to retention? Are there correlates to engagement and satisfaction? Are there correlates to data quality? And then I'll talk through a brief example of sort of earlier example of how we really did operationalize this in a very effective way. So our probability panel, it's a nationally representative panel, 18 and older, recruited majority from ABS now. We have some prepaid cell recruitment, and we have some RDD recruitment from the prior period of time. It is multi-mode capable, so we do not web enable our web reluctant panelists. We dial them. They are part of our CADI sample. So we have a live telephone interview available for those who don't wish to participate by web, and we conduct almost all of the studies in English and Spanish. So for this particular data that I was looking at today, it's an analytic sample of about 4,800 panelists that were registered from the summer of 2021, from a 2021 ABS recruitment wave. And we selected that wave because it goes back far enough that we have enough time on the panel for these folks to sort of start to understand how this Paradata works for them. Of these panelists, they were eligible for sampling into about 420 individual surveys between their recruitment and the present day. And all the data that I think I pulled data up through like 2 Fridays ago. And so, these were early in the life of the panel. The SSRS opinion panel started technically in 2019, but really started to ramp up in 2021. So it's a nice cohort to look at. And the survey volume has obviously changed over time for this group. So this was a longitudinal analysis of panelists by survey level outcome. I have a few dependent variables. The ones I'm mostly going to focus on are the probability of completing the first survey that they get, the survey level response for the subsequent surveys, and their sort of attrition risk. So, 5 or more non-respondents. That's not technically our definition of an attritor. We're a little more conservative than that, but that's what I'm using here. We had some other outcomes that I'll talk about, some data quality and panelist rating outcomes, but they ended up not being super correlated with the Paradata I was looking at. For most of these analyses, it was a fixed effects regression model that included panelist and survey level fixed effects. And almost all of the independent variables included a quadratic term because, as you'll see, they needed it. And I'll talk about the independent Paradata. So we have a bunch of independent variables, total, and these are just sort of graphs showing what the distribution looks like on the panel. So total survey invites per panelist, it went from 1 to a little bit over 80. The majority have gotten somewhere between 6 and 30 invites in this period of time that they've been on the panel. The bottom graph is invitations per month. The dotted line is the sort of maximum, and the dark line is the average. So in truth, our panelists generally get about 2 surveys a month. That's pretty standard and has been pretty consistent over time because as our survey volume has grown, so has our panel. So that's pretty much stayed constant. So, I mean, to be fair, this analysis, very few of our panelists are getting like bombarded with surveys. So I don't have a lot of data about what would happen if they were, but it's something to think about. I have a weeks to first invite variable, right? So we recruit them, we ask them to complete their registration survey and agree to be part of the opinion panel. They say yes, and then they are eligible for sampling into a study. They could be sampled the next day, or they could be sampled, you know, weeks later. So this variable sort of weeks before they were first invited to a study is really useful to look at. And the days since their last study invitation. So how long has it been since they were last invited to a survey? And then the last independent variable that I played with and really am still exploring is the study topic. So for every study that a panelist was invited to, we are trying to start cataloging what the survey was about. And it can get cataloged into sort of up to 3 different topics. You can see that a lot are still unclassified because we didn't start this classification process for a while. We do a lot of public policy and current event surveys. But I was curious to see if there were specific topics, and we chose the topics that we are keeping track of because we think either they make up a large proportion of what our panel does, the work our clients are doing, or we think they might be either super interesting to panelists or super sensitive to panelists, like talking about guns. We do catalog abortion. We haven't done any like that. We have a horse race. We are tracking, like, was this survey, did they ask them a presidential horse race question? So these sorts of things we'll continue to look at over time as we get more data. So looking at study level response, you know, does the number of weeks prior to the first study invitation impact the likelihood of response? And it really does. You can see, and we've learned very quickly that once they agree to be part of the panel, we really should sample them into a study as quickly as possible. So this is like showing the weeks till their first invite. And all of these graphs, by the way, are relative. So they're all sort of normalized. So the drop is, I mean, it's not 100% response, but that's the top, and then everything's relative. So you can see the drop off after like 4 weeks. We really should be starting to sample them. And then this graph is the same, but for whether they responded to one of the first 5 surveys that they got. So, okay, so maybe they get one survey, they don't respond. It's a little bit better, you know, you get them back a little bit, but there's still that drop. So this was clear indication that we need to get them as quickly as possible. And this is something that we are changing our operations to accommodate for, so that if they're not naturally being sampled into studies right away, we're going to make sure that they get sampled into engagement surveys and sampled into other things so that they are participating. So next we have survey non-response, like non-response to the subsequent survey. And the days since the last invite was my predictor here. So how many days has it been since we last asked you to be part of a survey? And it's really not related. So you can see that, like, how many days before is not super predictive of being sampled into the next survey. Interestingly, I started playing with, like, so cumulative invites, like how many, you know, invites over time. There's not a linear relationship. There is sort of a quadratic relationship, but it's relatively small, it seems like, at this point. But I'm gonna, at least for this non-response outcome, this like response to the very next survey that they were sampled from. But you'll see that this comes back in when we start thinking about attrition. Then I was playing with these, like, content of the surveys. So I created these variables that were like, what % of the surveys that the person has received were about current events or about health? And I even created one that was like, what percentage have they received that were sort of unique, so that they're getting kind of an indicator of, like, getting asked a lot of questions about different stuff. And interestingly, like, the % of the invites about current events if there's like a lot of them, if that's all they're getting, it does seem to impact their likelihood of like that very next response, which I thought was interesting. The health outcome is not significant. That didn't really have an impact. And this sort of different topics sort of did, but Mickey and I were talking about it earlier, and I really think this is just very correlated with the number of surveys they've gotten. And eventually, over time, after 80 plus surveys, you've probably been on the panel for 5 years, 4 years, and you're starting to, get bored. So looking at attrition episodes, days since last invite, this is where you can really start to see the impact of, so an attrition episode in this analysis was they have not responded to 5 consecutive survey invites. You can see a very clear linear relationship and apparently quadratic relationship between this. The bars or the lines are also sort of the days till the next invite. So that's the quadratic piece that you can see. And this really does suggest that, more might be better. They're at least at the level that our panelists are being surveyed, they're certainly not being over-surveyed. Similarly, this is the cumulative invites. It's generally pretty flat until, the 60 plus. I really think this is a proxy for just time on the panel, and that at some point you attrit. But what I found really interesting is that if you look at that, so if you look at that and break it out by this sort of proportion of surveys that have current events, which is one of our common topics, there's not really a big relationship. It's sort of the same as the regular one. But then when you look at it by health surveys, people that get a lot of health surveys are much more likely to attrit off. Like if most of the surveys they're getting are about health, it seems like they are more likely to attrit from the panel. Whereas a little bit less, as long as there's some mix in there, it doesn't seem to be making a difference. But I thought that was an interesting finding that we need to dig more into. Data quality failures. So we ask a few things on our panel. We do some trap questions. It's a rotating series and we're constantly trying to throw new things in. They don't get all of them. They get like one of them per every few surveys. And most of the ones on the left are these sort of questions like that come out of Pew Research, asking about very rare or non-existent things and seeing if they say yes to them. And then we have a true trap question, just sort of asking them to pick one of these answers. Our failure rate is really, really low. Out of all of our panelists by survey data, the failure rate is less than 3% for like failing one of these questions. And then if you just look at the panelist level, it's less than 10% have ever failed one over time. So it's not a big problem on our panel. This doesn't actually account for some of the other checks, the speeder checks, the things like that. I haven't gotten into that yet, but that's next on our list. And none of the independent variables were associated with this outcome. And similarly with satisfaction, so we ask our panelists, how would you rate your experience taking this survey? And in general, how would you rate your experience on the panel? Generally, our satisfaction is very good, but it was not related to anything else. And then also, if they do happen to say that it wasn't great, we ask them, what we could do to improve it. And, it's a mark all that apply. So send me more survey invitations is actually really, really high up there, as well as, of course, pay us more. Yeah. So, and again, no statistically significant associations. So a little quick Paradata in action, right? And this is actually from some data prior to this analysis. This was data that was conducted with a big swath of the panel. We did this analysis about a year ago from data from the beginning of our panel history mostly. And it looked at the likelihood to responding to a survey invitation contingent on having not responded to a certain number of prior invitations. And it was really useful in helping us understand what the intervention points need to be on the panel. So you can see that there's a drop off right away, right? Like, and this is typical on almost all panels, that they agree, they don't respond, then they, consistently don't respond. But we were really interested in figuring out when we should start intervening. So we did some analysis to look at what would happen if we had, scrubbed them. And by that, we mean sort of just retired them from our panel after 5 consecutive non-responses or 10 consecutive or 20 or 30 or 50. And you can see in this graph sort of what happens. And interestingly, the 30 and 50 definitely decrease the overall size of the panel consistently. But scrubbing the others, it's not making a huge, like if we start scrubbing at 10 or 20, it's not making a huge impact. And this would be the retention rate again. So, it's not a huge drop. So we're looking at this and we were looking at kind of one of those blue lines and thinking maybe that's the sweet spot as far as where we need to start intervening. And again, this would be just the average monthly level, right? Like if you scrub the panelists who aren't responding, you expect your response rate for any given survey to go up. And this is sort of the expectation about how much that would go up. And we want to optimize the increase in study level response rate without decreasing the panel size too dramatically. And then the overall is the retention by scrubbing. So we decided that at 10 non-responses, we will start a kind of chronic non-responder intervention where we go out and we mail to them and we ask them if they still want to be part of the panel, and we make a pretty strong effort to get them involved. If they respond, great, they're back in. If they don't respond and continue to not respond for another 10 invitations, then we retire them from the panel. And so this was our sort of chronic non-responder effort. And what I like about this graph, the red lines are the ones that we went out to try and get them back in, and they, by demographic, and they rejoined. And the green ones are the ones that never came back in. And you can see that like there are actually some of those really hard to reach demographics, like the less than high school, that respond really well to the intervention. So that's positive. All right, quickly, conclusions. Engage respondents quickly following empanelment. There doesn't seem to be a strong relationship between Paradata and individual study level non-response, but there may be some impact of that topical balance. We're not sure. Regular, consistent engagement seems critical to prevent attrition, and low survey volume seems to be a greater risk than too high survey volume. But again, we don't have a huge comparison group that has gotten bombarded with surveys. Some indication that panelists that receive a high proportion of surveys on a particular topic may be more likely to attrit, but more work is needed. And it's a really great tool for panel management. And in the future, Mickey is working on developing an attrition risk model. So we're really hoping to come up with a model that could really continuously identify panelists that are at risk of attrition and potentially modify the incentives, reach out to them, do things prior to the attrition and prior to them becoming chronic non-responders, and conduct a more comprehensive analysis of the conditioning effect, particularly on outcomes. There's some evidence that there might be a few outcomes like voter registration that may actually be impacted by being on a panel. So we want to look at that. And I want to bring in more of this questionnaire level data and get more nitty gritty about what we're actually asking our panelists to see if things are sort of triggering them to stay or go. Thanks.
Okay, great. Thanks, Cameron. Questions for Cameron? Starting in the room. Start here, Ipek.
So you mentioned, Cameron, you guys do retire, or what you call it, scrub, which I like the term, those who do not respond after recruitment. So those are backup respondents, right? So, and you mentioned, of course, these increase the survey level completion rates, but you also, how does this impact your panel composition, right? Like there's always this cost benefit of this whole retirement. And also, how does this impact your cumulative response rate? Because response rate, panel response rate is not just about completion, survey completion rate, but there are a lot of different steps, right? The initial recruitment rate, the retention rate, the survey completion rate. So how does that scrubbing affect all of that? And that's number one. But number two, I'm so curious about those interventions you talked about that bring in those subgroups.
Yeah, so I think the scrubbing, we have looked at, thank you. Oh, I can stand back here. I'll stand back here. We've looked at the composition and you know, as I'm sure you know, the groups that attrit are typically also the groups that are harder to get, that we want. But if they're not responding, but they're also the groups that our clients want us to be able to provide them. So if they're not responding to the surveys, then it just means we're having to send out larger and larger samples of those types of panelists. I would rather, you know, once I'm confident that they really don't want to be on our panel anymore, I would rather scrub those and then modify, you know, our kind of continual recruitment efforts for our panel is always based on the current panel balance. So if we are scrubbing more of a certain group of people because they're not responding, then we're going to up that group that we're trying to recruit in our next recruitment to maintain the balance and hopefully recruit panelists that are going to respond. And as we're learning from this, we're learning, you know, how quickly we need to reach out to them once they are impaneled. What kinds of efforts, you know, do we need to make to get them to stay on the panel, which we certainly have not solved that problem entirely yet. But I would rather have engaged respondents that are responding to the surveys I invite them to. And so I had a graph up there, but we did find this sweet spot where, like, yes, we're scrubbing them, so we're having to account for that in the retention rate, but the average study level response rate is going up meaningfully to the point that it's better, or at least, you know, maintains kind of a good average. And, you know, for any given study, I have confidence that the sample that I'm providing is this, for the most part, going to respond. So I have more control over that too. Your second question, the interventions. I don't have tons of details. I know that we've presented about it at some conferences, and we might be presenting at it more. I know it involves a mailing and some calling and some texting. I don't have all the details.
Wondering what that magic bullet was.
Yeah, no, I don't know. I mean, we're also experimenting with some recruitment non-response follow-up to bring in those additional groups as well. And potentially, if we come up with an attrition risk model, you know, our panel is already, the incentives are sort of tiered by different types of panelists. So we could incorporate that into the tiering of our incentive structure.
Rocco, did you have a question or?
Yeah, thank you, Cameron. This was fascinating. I actually have a question that's sort of related to everyone else in the room who works on similar panels. What you showed there on send us more invites and send us more money, which is kind of the same thing, right? Except that you sort of work for it more. Is that some, but also the information on the health survey, right? The mix of composition. I was just wondering if other panels looked at it similarly and if you found similar things. So, you know, looking at you, Ari, looking at you, Ipke, like I'm just wondering, you know, is there congealing a knowledge?
We're still looking at topics. I don't know the answer, but we had a meeting last week. So we looked at burden, and pretty much if you reduce the burden, reduce the number of invites, it seems to increase attrition slightly. So at least up to the level, which in our case is also maybe twice a month, maybe 3 times a month. more invites is not worse than fewer. So I think that seems to be the sort of stylized fact.
So one problem with satisfaction surveys, the people who respond to it are not the iterators, right? The non-respondents generally don't really respond to those satisfaction surveys. I mean, we did have similar findings where they said not more surveys, but incentives help, or we like the topics, like those things we found. But I think the core of the issue here is, those people, we already cracked the code for them. What happens to those? We just haven't cracked the code yet. And that's why I think the attrition risk model type of analysis are more needed here.
Okay, maybe some chat questions, and then we'll move on to our next presenter.
Okay, this question is related with the attrition risk model. The question is, what do you think the most crucial predictors of potential attrition would be in your developing attrition risk model, other than already having not responded to a number of waves?
It's a good question. I don't know if Mickey, I'm going to let Mickey answer that one because I'm not sure if we have a great answer.
I mean, at this point we have hypotheses. One thing that I suspect will show up as important is actually how many surveys they have attempted to respond to but screened out of.
Yeah.
We've gotten a lot of qualitative feedback that panelists hate that. So I suspect that might be might be a strong predictor, and that obviously points to maybe certain types of interventions that.
Yeah, which is great because that's actually something that's totally fixable. Right? Like it costs money, but we can fix it. Are we good?
Yep.
All right.
Okay, thank you, Cameron. Let's give her a round of applause again. Okay, now we're going to shift gears a little bit and get a little different perspective here. So next up, we have Cindy Ubartas all the way from Statistics Canada. So thank you for coming in person. She is going to answer the age-old question once and for all of how can we improve surveys by using Paradata. So we're glad to get those answers right now. Okay, Cindy.
Yeah, good afternoon. So I work in the collection planning and research division at Statistics Canada. And I'd like to apologize first because I thought I had 30 minutes. So I'll try to go fast for some of the slides we have there. So I'll start by providing a bit of context. So we have seen a decline in our response rates for social surveys like many other organizations. And of course, the pandemic has accelerated that. And one of the biggest challenges that we have in collection is actually the staff turnover. So the work environment for interviewers has changed a lot during the pandemic. We had a lot of people who quitted during the pandemic, and it's been really difficult to hire. We are still hiring. It's almost constant hiring. So we have a lot of interviewers who are inexperienced, basically. We also have expensive geography in Canada, so the majority of the population is concentrated in the south, but we have to cover the whole country to make sure we don't have any bias. So what's difficult is mostly in the north. Many communities don't have internet connectivity, and it's very costly to travel in the north. And sometimes during some periods of the year, we can't even go in the north. And if I want to summarize, we need to maximize responses with increased sample sizes because of the decline in response rate, but also because since the pandemic, we were asked to have more detailed information of some groups. So the sample size have increased a lot within shorter data collection periods because we need timely data too. And of course, when we have a lot going on at the same time, we have some capacity issues. So before talking about the Paradata sources that we have at our disposal, I just want to mention that my team is actually responsible for producing reports and analyzing Paradata files to try to understand what's going on in collection. and we do recommendations on what we can improve, but we are not the ones managing collection. In Canada, we have 3 regions who are actually doing collection and managing collection, so we are working closely with them to try to improve what we see with the Paradata. So we have 3 main Paradata sources for social surveys. The first one is the pay claims, and we use this mostly to try to see the collection hours. We have transaction files that records the survey collection operations. So most of our surveys are multimode. So we often start with what I call EQ, which is more push to web surveys. And then we will continue with at least CADI follow-up phone calls, and sometimes even in-person interviews. So we have information on all the attempts, you know, when people are going online, the logins, the results of this. We have the contact information. We have a lot of information available to us. And we also have the audit trails. So that records the interactions with the application. So we can look at, you know, when people are opening a page, closing a page, opening an help page, when edits are triggered, see if they're corrected or not. So we have all this information in our Paradata files. So the first thing we try to do in our division, actually, to be able to have like more timely data and improve our analysis, is to build a data warehouse. So we started doing this like 2 years ago. So the objective is really to centralize everything. We want to consolidate various data sources into one accessible location. So with this, we can have better analysis and faster too. So that includes our Paradata files that I just mentioned, budget information. We just built actually a budget application so that it goes directly into our data warehouse, and we can link those files. And we have information about survey development details and timelines. And the objective is to have one key identifier that will help us link all of this. So the objective is really to try to enhance the data analysis power. And we are planning to move all of our reports and Power BI so that like it's going to be better. And we are using this opportunity to actually consult our users to do some reports visioning. But in the meantime, in the last year, what we tried to do was to improve some of the reports that we already have for social surveys. So I'm going to go fast on this. I'm sorry this is small, but the objective is not that you look at the data itself. Like what I'm showing here is on the left side of the screen, we have total response rates. We also have total response rates per province, and we have it per mode too. And what we try to do is to add some colors to give some visuals. So on the right, what you have is actually what we only have for this survey. We have EQ, so online questionnaires, and then we have a CADI follow-up. So what we can see when we look at this is that CADI doesn't go that well, right? There's a lot of red there, but the total response rate is not doing too bad because of EQ. And actually during the pandemic and even now, that saved us a lot for some of our surveys. We're happy to have started having electronic questionnaires and online surveys before the pandemic. But one thing that we were only doing on an ad hoc basis, and now we have this on a daily basis, is our key indicators report. So there's more tables than this, but I just wanted to show you what we had to try to see how we can use this really to make suggestions on you know, where to put the effort. So first of all, when we look at the first table, this is actually telling us like the proportion of attempts that we have at every time slice. And of course, I always find that we don't call enough during the evenings and the weekends. But what we can see here when we look at region 4 is that it's even worse, right? Only 8% of the attempts when they're doing phone calls are done during the evening, and really not a lot, 10% during the weekends. So we talked to that region to try to see, could you change the scheduling of your interviewers to try to improve this. And one thing that we want to add is also the contact rates and the response rates per time slice to have like additional arguments to let them know that they should change the way they schedule the interviewers. And then if we look at the other tables here, what we have, the second table, it gives like for all the cases that are still in progress, where are they? So we see that we have 67% that had no contact at all. But we saw that we had approximately 9 attempts on average for those cases already. So is it really worth calling again? Probably not. But what we see is that we have 17% of our cases that are refusals, but not final refusals because they're still in progress. But when we look at that last table, we can see that we don't have a lot of effort that is put on refusal conversions, only 9%, and it's even worse for that region number 2. So what we said, because we were more towards the end of collection for this survey, is please put some effort on refusal conversions, because at least these people, they answer the phone, right? So you might have a chance, if you have more experienced interviewers that call them, to convert that refusal into a response. So that's the type of thing we're allowed to do with that type of key indicators reports now. We are also looking, because we have a lot of new interviewers, at the performance of our interviewers. So we look at some efficiency metrics. So basically, these ones will help us try to see, are they really working? Because all the interviewers are currently working from home. It's still like that, like when they do the phone attempts. So if we have, for example, a very low average attempt per hour, and that when we look at the activity code, they seem to be doing collection, then we can ask ourselves, what are they doing, you know? And we also look at the system time, so time that is spent on our collection system, the ratio between this and the hours that they charged to a certain survey. And we look at outliers, and if this is very low, then it's a red flag, right? Maybe these people need to be monitored a little more by the region. So we have that for them. And we also have like some performance metrics. So we look at the completes per attempts, resolve per attempts. So that can help, once again, when we look at the outliers, identify those who need training and perhaps some performance management. And at the same time, we can also see like the top 10%, for example. So those who are performing really well, then we can give them positive feedback, right? So that they're happy and they want to continue to do a good job, right? For our labor force survey that is held on a monthly basis, we also created a dashboard that includes the completes per attempt, but we also added another metric that we call the contact conversion rate. And this is actually, once a contact is made, what is the proportion of completed questionnaires? And the reason why we added that metric is that we identified that there was actually a difference by region on the contact rate. So in some areas, for some reason, people answer the phone much more than in other areas. But when we look at the performance of the interviewers, it's not really fair if we don't take that into account, right? So this is that contact conversion rate is a way for us to take into account that regional difference that we observed. And of course, like I'm just showing 2 months here, but we have like more than a year of data. So that can help like people try to see if, let's say they're monitoring some people or they're doing some performance management, is it really improving the performance that we see for these people? Another thing that we developed for now, it's only for in-person interviews, it's a geomapping tool. So we put on a map some of the metrics that we have. And the advantage of this for the regional managers is that there's actually like, for reports, it's like you saw, it's mainly by region or by province, but they can go and look at the neighborhood that they're responsible for. And one of the things that they have there is also the location, the addresses of the interviewers. So for example, if they have a bunch of not started cases and they have an interviewer that's close by that is ready to do in-person interviews, it can help them assign these cases to the right interviewers. One of the things that we added to is the natural disasters. So when we have floods or wildfires, this is like available on the map. So we can already see that there would be some areas that are impacted and that the response rate will be lower in that area given that. Right now, it's still a pilot project. So we implemented it for a labor force survey, which is one of our only mandatory survey, one of the most important one we have at Statistics Canada. And the data is refreshed daily during collection. And what we are doing is we are organizing feedback sessions with the managers who will use this in the regions to try to see if it was useful for them, but also how we can improve it, what we can add so that it's even more useful for them in their daily task, right? So this is what we're currently doing. This is just to show you an idea of what it looks like. So we have that first dashboard. They can either choose a region, choose a collection unit, and zoom on it, and they will be able to compare the response rate from their neighborhood to the national response rate. We also have details here in the tables. We have a lot of values, and it's dynamic, right? If I cannot show that to you right now, I cannot do a demo because it's an internal product, sorry. But yeah, they can zoom in and they will see the metrics for their region and also for all the interviewers. We have another dashboard, the interviewers and supervisors ones, where a supervisor can choose themselves and they will have information for all the interviewers they are responsible for. Or they can also only choose one interviewer if they're interested in looking at metrics for them. So that can really help them manage their day-to-day work. We have one that is called another dashboard, Other Geographies dashboard. For now, this is only at a placemat, a placeholder, but we did put some provincial level information in there. In the near future, we want to add some metrics. So the no contact rate, or contact rate has decreased a lot in some areas in the last few years. So we want to put that there, and also the refusal rate. And eventually, when we have more surveys, it can also pinpoint areas that are problematic. And we could try to see if we could do, for example, a bit of publicity there to help with our surveys. And another thing that we're still not sure exactly how we're going to do, but we want to take that into account is route efficiency. So when interviewers are traveling for work, they're going to claim a certain distance. So we would like to look at what would have been an efficient route and compare it just to look at the outliers for those who claim a lot compared to what we think they should have claimed. Now we do a little bit of adaptive design. It used to be quite better, but now what we do is pretty simple. For some surveys, we have a targeted approach. So for example, we're going to do online surveys like for all the units, but we're gonna do like a non-response follow-up over the phone, for example, just for a subsample of the units that is actually determined in advance based on the frame information they have and some historical information too. What we often do is we're going to use some of the functionalities that we have in our system to try to increase the number of attempts for some strata or some subgroups that are not performing really well throughout collection. So we can do this at any time during collection. And the objective is really to increase representativity. It works, but we still have some gaps, right? We have subpopulations such as youth and immigrants that remain underrepresented among our respondents in general. So what we'd like to do in the future is to, whenever possible, go from selecting households to selecting individuals. But of course, for this, we need a frame with all the individuals. But if we can get to that, then we could select like individuals, and we would have characteristics on them, and of course we would know their geography too. So that would help us have more of a tailored approach. So one thing we are thinking about, for example, would be to maybe develop customized invitations and approaches during collection for these specific groups that we know are harder to reach, or are usually not responding as well to our surveys. And last thing we did, which is a bit completely different, it's really just a research project. We're trying to see if we could use some of the notes from the interviewers when they're doing attempts, because for some reason we looked at, for some surveys, like some of the notes manually, and we realized that there are some interviewers who write down a lot of information in there. So we were like, in some cases, perhaps it could be useful to have this, maybe categorize these to try to see if we could better understand non-response factors or characteristics of non-response. So we started with our labor force survey. Since it's a monthly survey, we have a lot of data to work with. Something that makes it a little more complex, notes can be recorded in English or in French in our case. And we tried a couple of steps. So far, the results are mitigated. What we think is that the question might be too general. So we're going to try to see what we can do for respondents specifically, maybe for non-respondents, and improve what we've seen so far. So that's what I had for you today. So in general, we're really trying to look at the Paradata files to try to improve our reporting tools so that we can, of course, see how collection is going, but also see where to focus our efforts to maximize the impact on the response rate and improve the representativity. And of course, on the other side, because we always have a lot of new interviewers, trying to see where training and performance management is required. And actually, our geomapping tool can even tell us maybe that where we have some staffing needs, right? If we see that we often have a lot of cases in some areas, but we don't have any interviewer who lives close by, then perhaps they can try to target that area to hire some interviewers. And we explored the idea to use Paradata to better understand non-response. So far, the results are mitigated, but we're hoping to improve that. And one of the things that we also want to do, because we have the audit trails, and it's not all the surveys that use it. We use the audit trails a lot for a census. We need to study the questionnaire, like it goes to the whole population. But for a lot of surveys, we don't really use it. And sometimes I feel like we underestimate the impact of the content on the response rate that we get and the response behavior, really. So since we have some data, we're experts in collection, not on the questionnaires, but I would like my team to develop like basic reports that would include, for example, time per page, the questions where a large proportion of the respondents stop. Often we have a lot of edits in our surveys, but some edits are never fired, they're never triggered. Some are, but there's almost no correction made. So by having some metrics like this, then our subject matter experts could look at this and be like, okay, there seems to be an issue here. We'll go and look at the data a little more to try to see what we could do to improve content and eventually improve the experience that the respondents get with these questionnaires, especially for some that are quite long. So that's what I had for you today. Like, I don't know if you have questions.
Great, thank you, Cindy. Questions for Cindy? Any chat questions? Okay.
Okay, wait, that's... Thinking aloud, I'm curious to hear from any of the presenters today, how do we protect interviewers from potential adverse effects that could result from Paradata collection? In other words, how we do we pursue data collection efficiency and maximize data quality while protecting interviewers from feeling they are being surveilled and while considering ensuring human agency autonomy. That's like in general.
Basically, I think somebody asked a question like that earlier. How can we make sure that excessive collection of paradata, excessive monitoring of paradata doesn't put interviewers at risk or make them want to leave a project, since we're already dealing with a lot of attrition issues and so forth? And, you know, can we train interviewers to expect that paradata will be used a lot for monitoring and so forth? I think that's roughly what they're getting at.
Yeah, well, right now what we're doing is really, we will not necessarily fire an interviewer because they don't really have good performance. The regions are really trying to work with them to improve what we've seen. And of course, like it's going to take a long period of time because, you know, for them to improve, like it takes a lot of time. It can be different too, depending on the survey they're working on. There are some surveys that are maybe more popular than other ones, right? Depending on the topic, depending on the length. For example, a lot of our health surveys can last an hour. It's different to work on this than to work on a survey that does last 20 minutes. That is for the general population. So that's why we're really just trying to look at the trend overall and improve this. Of course, if after 1 year or 2 years, like we don't see an improvement, then that could be different. And I think what the red flags and what could cause the issues is mostly the first, like the efficiency matrix I was showing. So if they don't seem to be working the hours that they're saying they're working, this can be more problematic for the interviewers, of course. But in terms of really performing, having completes and everything, if they seem to do the effort, I don't think that could be an issue. It's just their regular work, right? So.
Yeah, thanks. That's it in chat. Oh, yeah, Ipek.
So, do the interviewers have access to these dashboards? And you may have already mentioned this, or these type of tools, or is it just the managers or the methodologist? And then the second question is, have you done any UX design or usability testing? I mean, it looked really cool, but I'm just curious, like from a user's perspective, if you got any feedback on that too.
No, well, it's actually like for the reports in general, it's mostly for collection people. So the regions and people in my division, for example, we have some reports that we can provide to even like internally subject matter experts or methodologists. But for example, they won't see like data on the effort and only the regions have access to the regions and us, of course, because we do it, have access to data related to the interviewers. Like no one else, even at StatScan, can access this. It's really the regions, and it's for performance management. Like the people who are involved on the surveys, like do not have access to this. So yeah, we have restricted access for most of our reports.
Okay, any other questions? Okay, all right. Thank you, Cindy, very much.
Thank you.
Yeah. Okay, our final presentation of the day is going to be remote. So, yeah. Yeah. Okay, let's see. Hanyu, can you hear us okay?
Yes. Can you hear me all right?
Okay, yep. Yeah, we can hear you too. We're going to mute the room here in a second. So, okay, yep. Okay, so Hanyu Sun is coming to us from Westat, and she's going to talk about the use of recorded interviews as paradata to explore the interviewer-respondent interaction by mode. So, Hanyu, you can go ahead and share your slides, and we'll make sure we can see them. Okay, looks great. So I'm going to mute the room, and you can take the floor.
Sure. Thank you, Brady. Good afternoon, everyone. So today I'm going to present the use of recorded interviews as paradata to explore the interview-respondent interaction by mode. And first, I want to thank my co-authors, Brad Edwards and Ting Yan, for their contribution on this project. So computer-assisted recorded interviewing, or CARI, has long been used by survey organizations to monitor interview performance and assess survey questions. So CARI produces question-level audio recordings that capture the interactions between the interviewer and the respondent. Interviewer monitoring often aims to detect interview falsification and undesirable behaviors. Question assessment often aims to identify survey questions that may introduce measurement error. So to use CARI, conventionally, a human coder needs to first listen to the audio recording of the interactions between the interviewer and the respondent, and then evaluate and code features of the interaction or the question and answer sequence using a pre-specified coding scheme. So for examples, with interviewer monitoring, the coding scheme can be designed to identify interview falsification by asking coders to indicate how likely the interviewer fabricated the whole or part of the interview. In addition, coders are asked to assess how closely the interviewer followed the standardized interviewing protocols, such as whether or not the interviewer read the question verbatim and whether or not the interviewer probed in a non-leading way. So coding of the question level recordings can be further aggregated to provide respondent level or interviewer level evaluations. And often interviewers who are identified to have deviated substantially from the interviewing protocol are called out for interventions such as retraining. And although it is a very effective tool, the conventional CARI coding tends to be label intensive and time consuming. So as a result, in practice, only a small proportion of completed interviews or a selected group of key survey questionnaire items are selected for coding and evaluation in a timely manner due to resource constraints. So what do we mean by question answer sequence? So in standardized interviews, the interviewer and the respondent follow the paradigmatic question answer sequence. So interviewers are expected to start by asking the survey question verbatim, and the respondents are expected to reply with an adequate answer or by select one of the response categories provided. Sometimes interviewers end the sequence in a third conversational term by acknowledging the answer. So deviations from the paradigmatic question answer sequence occur for various reasons. For example, a respondent may not understand the question or have difficulty answering it. So here we have one example. So in this example, there are 3 turns, including 2 turns from the interviewer and 1 turn from the respondent. The interviewer asked the question at the first turn, and the respondent provided the answer immediately at the second turn. And then the interviewer acknowledged the respondent's answer by saying thank you at the third turn. So that's a typical example of a paradigmatic question answer sequence. Okay, so at Westside, we developed a machine learning audio pipeline to process and analyze audio recordings of survey interviews in real time with low cost. So the pipeline is used to identify and sample interviews with high risk of being falsified, interviewers exhibiting undesirable behaviors, and a survey question with poor performance and prone to response error for the conventional CARI coding. So the goal is to improve the efficiency and effectiveness of the conventional CARI coding. The pipeline, as shown in the figure here, the pipeline includes 3 components, processes built on pre-trained machine learning models: speak diarization, speech to text, and acoustic feature extraction. So the speaker diarization process determines the number of speakers and produces conversational turn level metrics. For example, the number of turns and the turn duration. The speech to text process transcribes the conversations at the turn level and produces metrics to evaluate interviewer question rating behaviors. And finally, the acoustic feature extraction process produces acoustic parameters at the turn level to predict respondent emotions. So these metrics are informed by survey methodology literature and are designed to facilitate quality control at 3 different levels: interviewer level, respondent level, and survey question level. And the projects can choose which level to monitor based on their specific quality control needs. In addition, the pipeline has an optional sampling process that can select interviewers, cases, or survey questions for the conventional CARI coding. So next, I'll provide some additional information about two of the processes in the pipeline. So the speaker diarization process use pianoed audio pre-trained models to determine who spoke at which turn in a question-answer sequence. So at the end of the diarization process, the number of different speakers is output for each question level audio recordings. So since the paradigmatic question-answer sequence involves only two different speakers, the interviewer and the respondent, recordings that are detected to have 0 or only one speaker are automatically flagged by the pipeline to be at a risk of interview falsification. This process also produces some turn level measures such as number of interview turns, number of respondent turns, and turn durations. The second component is the speech-to-text process. So that's where we used OpenAI Whisper pre-trained models to transcribe conversations at turn level. The pipeline subsequently compares the turn level transcript to the exact question wording from the survey instrument, producing like distance measures on lexical and semantic similarities. So we use, for a lot of survey at Westside, we're using BLAS to program the instrument. So we use OCR text recognition to extract the exact question wording from BLAS screenshot so that auto files such as respondent name and address can be captured correctly. And then the pipeline used the distance measures to evaluate to what extent the interviewer read the question verbatim and to what extent the interviewer maintained the question meaning. So interview reading verbatim is the lexical comparison of question read through transcript to the reference question text. It is measured as 1 minus the word level jacket distance. And then the interviewer maintaining question meaning is the sentence comparison of question read, it's the semantic comparison of question read through transcript and the reference text. We first obtain the sentence embeddings for both the reference text and the transcript, and then we compute the cosine similarity between the two. The semantic distance is measured as 1 minus the cosine dissimilarity. So for both the jacket and cosine distances, a larger distance measure suggests that interviewers are more likely to not read the question exactly as worded and to not maintain the question meaning. So interviewers with large distance scores will be automatically flagged as showing undesirable question reading behaviors. So regarding interview performance for validation, here I just present some data. That's where we compare like two of the pipeline measures with the coded results from the conventional carry. So data was from a national representative survey of the US civilian non-institutionalized population. The data presented here was from 464 interviews that were processed through the pipeline, as well as reviewed by human coders. So as stated earlier, the larger the distance score, the less likely the interviewer read the question verbatim or maintain the question meaning. So the results are in the expected direction. As the coder rating changed from excellent to poor, the distance score increased. So meaning less likely, the interviewer less likely to read the question verbatim and were less likely to maintain the question meaning. So regarding the second utilization about the pipeline is questionnaire, like survey question assessment. So regarding question assessment, the pipeline produces flags to rank survey question on set of performance measures based on literature of interactional analysis of a question answering. So again, as stated earlier, a paradigmatic question answer sequence is composed of one turn by the interviewer who is supposed to read the question verbatim and one turn from the respondent who is supposed to provide an adequate response. Any departure from this paradigmatic sequence indicates that there are problems with the question answering process, speaking to the poor performance of the question. So for instance, questions inducing more than one respondent turn suggest that respondents are likely to have asked for clarification, asked to repeat, and maybe expressed uncertainty with answer. So the more respondent turns a survey item produces, the more problematic the survey item is. Similarly, questions invoking more than one interviewer turn indicate that interviewers are likely to have reread the question, probe for clarification, or provide a definition, and so on. So the more interviewer turns, the higher chance that the question performs poorly. And finally, a long pause after the interviewer finished asking a question and before the respondent's first turn speaks to difficulty, the respondent may have experienced while answering the question. So all these measures are then aggregated to survey question level to rank their performance. And similarly, such results can be used to prioritize or sample survey question for conventional carrier coding by human coders. So next, I'll present a case study showing how to use the pipeline measures to understand interviewer-respondent interaction by mode. So first, some background information. So recent study, recently researchers have investigated response behaviors between live video interviews and in-person or telephone modes of data collection, and have reported finding many mode differences in satisfying response behaviors, in respondent experience and satisfaction, in rapport, and in key survey estimates. Research comparing the three modes on interaction and the speech behavior is limited. So here I listed some of the relevant research. So interviewers read question verbatim more often during telephone interviews than in-person interviews. A different study found that interviewer read question verbatim in live video interview more often than telephone interview, but less than in-person interviews. Interviewers make a question meaning of the question meanings are more often in live video interviews than in the other two modes. And there's another study found that compared to telephone interviews, in-person interviews led to more conversational turns and more conversational events. And the variability in interaction is largely due to question characteristics. So with this study, we aim to address two research questions. So first, how do in-person, live video, and telephone interviews differ in standardized interviewing behaviors and interactions? Specifically, we're looking at three outcome measures: interview reading verbatim, interview maintaining question meaning, and the total number of turns in the question answer sequence. Secondly, how do question characteristics affect interviewing behaviors and interactions? And here we'll focus on two specific question characteristics: single choice versus marker that apply question, and whether a show card is being used for an item. So the data presented was from a nationally representative survey of the US civilian non-institutionalized population. The study was a sequential multimode design. The mode was not randomized. Instead, interviewers offer respondents one of the three modes first based on the protocol. And if non-response to that mode, the interviewer switched to another mode in a prescribed sequence. So our total of 54,729 audio recordings of the interview respondent interactions were processed through the audio pipeline. All of the audio recordings are at the question answer sequence level. The data set includes 692 live video interviews, 835 in-person interviews, and 780 telephone interviews. So a total of 236 field interviewers conducted all these interviews, and a total of 44 survey questions of varied characteristics were recorded and processed through the pipeline. We accounted for clustering by interviewer, respondent, and question by fitting a two-level cross-classified random effects regression model for each outcome measures. So with the outcome measure cross-classified by respondents and questions and nested within interviewer. We added mode and question characteristics as predictors, and respondent characteristics, including age, sex, race, ethnicity, household size, education, and interviewer characteristics, including age, sex, race, ethnicity, and education as control variables. So the outcome measures, as mentioned, are the three measures produced by the pipeline, including interview maintaining the question meaning and the total number of turns for question answer sequences. And as stated earlier, the interview reading verbatim is measured by the jacket distance. And the higher the jacket distance, the less likely the interviewer read the question verbatim. The interview maintained the question meaning is measured by the cosine distance. The higher the cosine distance, the less likely the interviewer maintained the question meaning. The last outcome measures the total number of turns made by either the interviewer or the respondent in the question answer sequence. More than 3 turns suggests the deviation from the paradigmatic question answer sequences. The independent variables mode and the question characteristics, as I mentioned earlier on. So we first examined how mode affect outcome measures. So the figure on the left represents the interviewer reading verbatim by mode. The figure on the right represents the interviewer maintaining question meaning by mode. Again, the larger distance scores, the less likely the interviewer read the question verbatim or maintained the question meaning. Okay, so as shown in the plots regarding interviewer reading verbatim, interviewers in the live video were more likely to read the question verbatim as compared to those in person and telephone interview. So if you're looking at the bars slightly shorter for the live video interview as compared to the other 2 modes. Regarding maintaining meanings, interviewers in live video were more likely to maintain question meaning as compared to those in person and telephone interviews. The differences were small but statistically significant. This figure shows the number of turns by mode. We didn't find any significant difference between the 3 modes on the total number of turns for the Q&A sequence, question and answer sequence. Next, we examined how question characteristics affect outcome measures. So we first look at single choice versus marker that apply choice items. The figure on the left represents the interview reading verbatim by single choice, yes or no. And the figure on the right represents the interview maintaining question meaning by single choice item, yes or no. So as shown in the figure, interviewers were more likely to read question verbatim for single choice item as compared to marker that apply items. Regarding maintaining question meaning, interviewers were more likely to maintain the question meaning for single choice item than mark all that apply items. So this figure shows the total number of turns by single choice item, yes or no. And as we can see from the figure, compared to mark all that apply items, the question and answer sequence for single choice item had fewer number of turns. So next, we looked at items with and without a show card. So the figure, again, on the left represents the interview reading verbatim by show cards, yes or no. And the figure on the right represents the interview maintaining question meaning by show card, yes or no. So as shown in the figure, our interviewers were more likely to read the question verbatim for items without a show card as compared to items with a show card. And regarding maintaining meaning, interviewers were more likely to maintain the question meaning for items without a show card than items with a show card. So this figure represents the total number of turns by show card, yes or no, and there were no significant differences between items with and without show card on the number of turns for the question and answer sequences.
Heine, you got about 5 minutes, okay?
Okay.
Thanks.
And finally, as a conclusion, so regarding mode, we found that interviewers were more likely to read verbatim and maintain question meaning in live video than in person and telephone interviews. There were no significant differences between mode on the total number of turns. Regarding question characteristics, we found that interviewers were more likely to read verbatim and maintain question meaning for single choice items than multiple choice, than marker that apply items, and for items without show cards than item with a show card. We found there were fewer number of turns for single choice than marker that apply items, but there were no significant difference between items with and without show card on the total number of turns. So for future research, we will expand the analysis of the interview respondent interaction by mode to include additional measures from the pipeline, additional question characteristics, and also the interactions of mode by question characteristics. We're also interested in examining the various components to say how much the interviewer, the respondent, or the question contributed to the overall variance. And speaking of the pipeline, we will utilize human-coded results from the conventional carrier coding to improve the performance of the pipeline. And finally, a challenge more of a future research is how to introduce the pipeline to new users or stakeholders about what it can and cannot achieve. So as I mentioned earlier, the goal of the pipeline is not to replace human coders. Instead, it is to make the human coders work more efficient and effective, so resources can be allocated to review cases that are most likely to be problematic. How to get buy-ins from various stakeholders in these areas worth further exploration. That's all I have for you today. Thank you.
Sorry, I didn't get to the mute button enough, but you just got a round of applause. So you may not have heard it, but it was a very good talk. Thank you very much. Okay, questions for Han Yu? I think I saw one in the chat, yeah.
First one is, how is noise roughness of the pipeline? Did you try with or without noise backgrounds?
Right. So yeah, I see the question in the chat. Thank you. Yes. So I think this is a no issue for speech text. When the question is when you have a lot of background noise, the diarization components may not work very well. Embedding acoustic feature likely to will be also beneficial. Yes, I agree with that comments. Someone asking about, do you think automatic embedding or acoustic features like wave to whack will be also beneficial? Yes, we definitely think that will be helpful. And then how difficult it be to build a pipeline like this for others, including memory? So right now, with Whisper is an open source model. It can process recordings in many different languages. So I think that is kind of being resolved. And how difficult would it be to build a pipeline like this for others? All the models as mentioned about, we're using pre-trained models, they are all open source. It's a matter of putting different pieces together and having some, I think it's more about how to interpret results. That's where we rely on the literature from survey methodology to guide us our decisions on how to interpret the results.
Okay, other questions in the room? None in the chat? Okay, well, I don't see any questions in the room, Han Yu, so thank you again. Very interesting presentation, very good work. So let's give Han Yu a round of applause you can hear.
Thanks.
Okay, well, thank you, everybody. I know that's been a lot to digest, but a lot of very interesting work going on. So today, the focus was largely methodological and operational in nature with the talks. Tomorrow, there's going to be more of a focus on how to use Paradata like we've been talking about to enhance substantive research. So that's going to be a big focus of our talks tomorrow, but we'll also hear some more methodology mixed in. And then tomorrow afternoon after lunch, we are going to have lunch in the room for everybody. So please do plan to join us for lunch if you can. But we're also going to have a panel tomorrow after lunch that's going to kind of synthesize everything we've heard here and try to develop an agenda for future research in this area, which is going to be another product of the workshop, hopefully. So definitely stay tuned for that tomorrow at 1 o'clock. For those of you who are here in Ann Arbor, we will also have breakfast here in the morning. So please join us around 8:30 for that. And we'll have breakfast before the talks get going. Okay? Okay, if you are in Ann Arbor and looking for dinner options, feel free to grab somebody from ISR. Some information was also shared about popular restaurants in the area. But feel free to ask anybody at Michigan and they'll give you their 2 cents about what you can do this evening. So, but yeah, thank you everybody today and we'll look forward to seeing you tomorrow morning. So thank you.